Right, I'm finally here. How's it going? Who we got here? David? Ian? Recalls, I've forgotten your name. I know you did change your name, didn't you? Your online name. So if you're here, say hello to chat. So I know who's here. The analytics on YouTube's looking a bit rubbish. It's showing like nothing. Again, didn't do this last time. Yeah, it's like I know there's people here watching because I can see you, but it's also showing there's no one here, which I know is not right. I've got a different screen. It shows us currently 8 people. So, oh, there we go. It's finally updated. Wow, that's super fast. Anyway, yes, there's 9 people. Okay. So, we've got to tinker with a few things today, I think. We'll see how we go. Got some stuff you wouldn't have seen yet. There's a pile of it on the desk behind me there. So, some things we could look at. But I've got something on my desk right now which I want to do today. I'd like to fix it today. So, we'll get to that. And it just arrived this week, so you guys wouldn't have seen it at all. I've got, I think, 3 mailbag videos already recorded, queued up. No, I'm not. My wife is keeping herself busy when I'm busy. She's working on some of her own projects whilst I'm working on mine, I suppose. So she's back from Europe now, and she's just doing her thing. But yeah, so I've got one thing on desk right now which I want to pull it back apart and try and fix. I've got some ideas of where to go, but that could take us a little while. We'll see. Could be an interesting one. And if we do get that one finished, which I expect we will, I hope we will, then there's this pile of stuff behind me which also needs doing. So, we can work through those. I've got, basically, I did the auction score, right? And I've got a whole bunch of videos about the auction score stuff I got before. I think I've got 4 or 5 videos there queued up. Let's have a look. They'll be doing, once I get into them, I'll do them like once a week. There'll be one every Friday, I expect. Yeah, I've got 4 videos there for auction score stuff. And I've done another auction score. So I've got to, these are part of that. And so they will need to be done as well. So I'll probably do a big series for probably a couple of months, auction scores on Fridays or something like that. We'll see how we go. So that's the plan for those things. I thought it'd be interesting just to do a big series of what I picked up and what they are and fixing them up as we go through. Just a whole bunch of random things I picked up because they were cheap. Do I need any of them? No, mostly not. But doesn't matter. So the chat's very quiet. Is this thing playing up again? Or is everyone just quiet? Don't forget, part of this is that I'm interacting with you guys. I could just do a video anytime. So interaction is the part of the reason for doing the live stream. So if you're here, say something. Let's give you a sneak peek of that. Okay, Ian's right, so that's good. It's definitely working. Okay, let's do. It doesn't quite show it. The top left corner there. Yeah, I'll do a wider view. Yeah, there's that meter sitting right there. I want to work on that. Thanks, David. Yeah, I mean, it's something I wanted to do anyway. I actually already asked Ian if he was going to do it because I knew he had some 2001s, and being as Ian's done a lot of the work on these projects before with this particular display that was used with the STM32 setup. I know Ian was busy though, so he didn't really have the time to do anything with it. And then I saw some people on EVblog forum had also done a little work on that with OLEDs, with Raspberry Pi, I think it was, they were doing it on. And I had some interesting information about the actual decrypting the coding and stuff like that from the display driver. So they had some information there which gave me a bit of a starting point. So it's like, okay, I know what the communication specs are, and I know what some of the data is. So from then I started sniffing myself and found out everything I needed to know, I think. I mean, there could still be stuff there which I've missed. It could well be that there's other things which don't normally show up that might come up and then be handled weirdly. I don't know. It's what I've released so far is like, well, yeah, it works. It seems to work correctly. Could be improved upon, absolutely. One thing I'm still happy with is the main font. I mean, it works, but I don't like the spacings and stuff on it. It's just there's still stuff which needs tweaking. So I probably will revisit it myself some more at some point and do some more on it. Right now I've got a working 2002 with a nice display on it, so I'm fairly happy. And if someone else finishes the code off and does a better job, finalising some of the other bits which I haven't really finalised, and I like getting a really not nice solid main font which is monospaced, that sort of thing. If someone else does that, great, then I'll adopt their code. That's fine. One thing I've got to do is I think I need to change in the code. It actually is limit how quickly it can write to the actual screen itself. Because I think some of the artifacts, like not the artifacts, but glitching you might see on the digits where it sort of flickers a little bit. I think that's to do with how quickly it's writing to the screen. I think it's trying to do it too quickly. So I actually think I need to scale that back a little bit and actually say I need to write every 10 milliseconds or 50 milliseconds or something like that. So it doesn't try and write too frequently. I think that might be what's causing that. I might look at that again at some point and figure that bit out. But that'd be easy to do. Just put a timing thing in the code where it actually writes to the screen. Just put a block around it and to say if it's been more than this amount of time elapsed, then write to the screen. Otherwise, don't. That would actually, as long as it's fast enough for you to read, like say 25 frames a second, for example, that'd be what, 40 milliseconds. So if it's like 40 milliseconds update rate, which is slow for microcontroller, that would be enough to at least give you a nice smooth display, I suppose. Yeah, it worked. I mean, I've actually, it would do it. It would go fast. It can actually keep up. But the faster it goes, the more glitchiness we're getting, which makes me think that it's to do with the writing speed to the display, which is why you get those glitches. So I think I need to slow it down a little bit. The actual writing to the screen part. I mean, you can't read when it's going that fast anyway. You can see a trend. You can't really see. You can't really read it, can you? So you don't need to go that fast. So slowing it down a bit in the code is probably a sensible thing for reliability and improvement. So actually, should we go into the code? Let's go into the code. Let's pull this thing up. I'll just stick this up here so you can see it. Apparently I've got a bunch of updates. Of course I've got updates. I don't know how big this is going to be on screen. Let's have a look. So there's the code, there's all the header stuff. So what I've ended up with, which isn't in that video I did, is I've got 11 colours. I changed the colour schemes around to try and get a nicer choice of things that show up well for the screen, the actual tinted perspex at the front. So these 11 colours seem to work quite well. I found I've got like a light blue here, sky blue. That was a nice one that came through, and so did a cyan. those ones came through really well. But obviously you want contrasting lines and stuff like that. So I've put a range in here. So I made it to 11, so it just wraps around through them all, and people can choose what they want. Or if somebody really wants to, they can choose other colours and put them in here. Also got a flag here set for the number of colours are present, right? That is used because it needs to know how many colours to go up to. Of course, you could just count the array, but I've done it this way. And down here, I've got it in the EEPROM stuff. Has to be less than the number of colours in EEPROM coding, right? So if it checks for being out of range, and if it's out of range, it'll go to a default number. So it's like a fallback thing. But yeah, don't care about that right now. Colour changing stuff, don't care about that. That's outputting the serial information if you need it. It does that when you change colours, so it tells you the colour numbers through the serial interface. So if you're changing colours, you're not quite sure which ones it's actually using. It spits it out over serial through the USB. So you can give you the numbers you're actually using, so you know which colours it's currently using on screen. That is hard coded in there, it's not turned off. But the actual sending of the data, like the actual screen information, to the serial port is disabled unless you uncomment it, because you don't really need it unless you want to enable that feature. Hanging the serial here, that's obviously just grabbing actual data, and this is for checking the screens it's using. Boot screens, it's got 2 potential boot screens, as I mentioned in the other video. And this is getting the boot screens, how to handle those. And second boot screen tells you how to handle that one. You've got the flags, it tells you how to handle those. So it's doing conversions from the bytes. Then you get the main display screen, which does conversions from special characters, so it knows how to display them. So if there's anything else that comes up, so I'm going to drop them in here. You know, some other special character I've missed. Like, I'm suspicious that there's a 10 and a 12 here, but there's no 11. So I'm thinking maybe there's an 11 character somewhere. And I think there's another one. There's a C, yeah. 1B, 1D. I think there's 1C which isn't in here. So there's a couple. I think actually 1C was one of the other special bars or something. I can't remember what it was now, but yeah, there was something I didn't actually handle. So there's a couple like that which might need adding by someone. And there's a do display bit which actually does actual displaying, conversion to the center to the screen. So if I wanted to slow this down, I could just put a block around this section, around this do display one. And I'll just put a block around that and say if it's been more than this time elapsed, then display it. Be easy to do. In my loop here, I've got this. I always use this piece of code in my stuff. So this last millis equals millis. I'll do that so it does less millis calls, because when you're doing millis, it actually takes a few process cycles. Whereas if you store it and you're looping frequently, it is constantly looping. It's safe to do it. But if you're stepping through branches and stuff like that, it could be a bit of a problem. Something to keep in mind. Sometimes we'll call it again. But I save as last millis, and that way I can do a check. Say if current millis is different to last millis, so I can update or something like that. But it depends what I'm doing. But yeah, I'll do a check for millis, and then you can do a check across that and go, right, if it's been more than 50 milliseconds or 40 milliseconds, 25 frames, then it'll update display. I could do that very easily. So I probably will add that to it and update that onto my GitHub. But yeah, that's what I've been working on. So yeah, hopefully other people will grab this code, adapt it a little bit, and make it even better. I mean, obviously I've done a very basic display. It could be made much nicer. It could do all sorts of flashy display stuff. Because it's a TFT, multicolour TFT, you can, I think it's like 65,000 colours you can do or something, I don't know. But yeah, it can do a lot. So someone could definitely do things like make the display prettier, and you know, there's a few little font things which I'm not 100% happy with it. They work, but I would like them different, like this. The fact that main font isn't in monospace, Like when you boot it up, the 2002 is off to the left because the spaces are narrower than the characters. Some find the character's not right. Yeah, exactly. Also, because I'm not used to doing publicly available code like this, I've also done a binary file for this. I've done a binary export and made that available, so people can just hopefully dump the code on to the device without having to worry about libraries. When you're doing this sort of stuff, getting the libraries and making sure you've got the right versions of the library can be a problem. I know there are some stuff I've worked on with some other TFTs, like 3.5-inch TFTs, where you had to write into the library which screen it was. You'd modify the library file to say, oh, it's this screen. And when you update the library, when you update the library, it reverts back to default. And so you have to go back in there and rewrite it. So the chance of someone having the same settings on their screen in the library is slim. So this is different though. This Adafruit one seems a bit more evolved, and so you can specify it in the code here, which is what this is doing. I've left it all in here for different screen types, the most likely ones to get used. We've got a 4.58, which is obviously what I'm using, and we've got a 3.7 and 3.2. I left those in there for people to potentially use this code for something else. So it's just easy to uncomment and change. But one thing I'm thinking of is maybe potential glitching is because of these, or at least this line here. So it's got timings and stuff in here. Sorry, those ones there, get it right. These timings here, those ones. So horizontal sync and vertical sync, and front porch and stuff like that, back porch. Those timings are specified in their default code, so that's what I've used. I haven't tuned any of these. So if there is anything with glitchings, it might be that these numbers need changing. I don't know what you got in when you did yours. So I don't know if these numbers compared to what you were getting in. I don't know if it will be even comparable because you're using a different controller. I don't know. Gary, yeah, I've replaced the display now. I did a video on Friday, which I'm guessing you haven't seen yet. Well, I've replaced this display with a TFT, and the brightness is, I'm actually referring to the fact that I'm only running 25 milliamps, maybe referring to that. I did try 50 milliamps brightness, and yes, it was brighter, but what I found, at least when it wasn't behind the perspex, right, when it wasn't behind the plastic, just I was doing it before I installed the thing, is that the black background on the TFT also brightened, so it lost contrast in that way. So although it's brighter, the contrast didn't really improve that much. So, I mean, being behind the tinted plastic might make that okay. But I was thinking, well, yes, it can do 50 milliamps. That's what it's designed for. I expect it has 50 milliamps. But I don't like to drive things flat out. I always like to. They say, I can do 50 milliamps. Well, I don't want to do 50 milliamps because I want it to last forever. I don't want it to fail in 5-10 years' time where it's burnt out because it's been driven to the max. Same thing for LEDs, right? Normal LEDs, I don't drive them to the max. Always back it down at least 10%, so they last much longer. So I always do that. Like backlights on monitors and screens and everything, always turn them down so they last forever. And because usually the full brightness, you don't need the full brightness. Your eyes adjust. Your eyes adjust to it. And so I'm still running 25 milliamps on that screen, and I've been happy with it. I've got it sitting up here behind me right now. Probably can't see it. Yeah, just there. So, no, it's not a set shot now. At least it isn't a shot. Let's go here. There you go. It's sitting right there right now. It's in the stack. So there's the 3458A with the 2002 on top of it. I've taken away the Advantage 6581T. I don't need that one anymore. I've actually got that for sale. Haven't had any takes as yet. I'm trying to set up an auction site locally, but it's not cheap, so I want to try and get some money back from all the money I've been spending this year on bloody expensive multimeters. Hey Rob. Yours are different as well, yeah. You did watch it, cool. Yeah, well, the thing is, I don't actually have any way of checking whether the driver. Well, because I'm not using the same driver you're using, Ian. It's because the ESP32S3 is handling everything. There's no intermediate driver. So where you're using the, was it LC, whatever the hell it is, I've forgotten what it is now. 7220 is it? I can't remember. Whilst you're using that standalone driver from my display to control the LCD, well, TFT, you need to program that driver, then have the driver communicate to the screen. And so obviously you've got those extra steps which take a bit of time. Whereas I've got the ESP32 talking straight to the screen. So don't have that intermediate step. So I think that probably helps a bit with the speed. The only thing I've seen is that we get the flickering numbers. Numbers will flicker, I think, if I'm trying to do it too fast. So I think it's just like an update rate to the screen rather than getting screwed up. So I do want to slow that down. So I'm actually thinking I might just do that now. Let's just do it now, a little bit of code, then we'll go and fix some electronics. Let's do this. Because I think this will be fairly straightforward. So I can do a really basic block around this. Let's just shove it in here somewhere. Just make sure I'm going to put it in the right place. That's handling, updating, and updating the text. Yeah, I don't want that one. I want this one. Do display section. So this bit which actually handles the display. So let's actually do. I don't know how well you can see what I'm typing. It's going to be pretty small, I'm afraid. There's no flag I know about. I mean, there may be one, but it's not documented. I've seen. It's obviously built into the Adafruit graphics library, so maybe it's commented in the library somewhere saying how to do it. It's possible. But right now, I'm just writing flat out to the screen, not limiting it at all. It's just as it gets there, it writes it, which I think is probably not a good thing. So I think I'll just say limit it to a certain frame rate. So what should we call this thing? Last display, right, call it that. How should I call this thing? I promise trying to talk to you guys and do this at the same time. I have to think about what I call this. Hold on. Come down here. Let's do the bracketing stuff first. So I'm just going to put the whole thing into a little if statement, into a check. There it is. Let's just call it this. Let's just do it this way. I'm actually going to break my own rule, what I was saying before. Let's do that. I'm going to call it multiple times just because I want to make sure the timing's good. Okay. Sometimes you want to do precise timing. So let's come in here, and at the end of that, before it drops out, equals millis plus what do you want? 40 milliseconds, eh? 40,000? That's right, it. Was that? That's 40 seconds. Yeah, that's not wrong. That much. That'd be what I want, isn't it? Or is that too long? 40. What am I thinking about? Jeez. Okay. Let's write this up here. Shove it in here somewhere. Shove it there. And so that should at least sure it compiles. Should compile. What have I missed? Oh, typo. Yeah, compiles fine, great. So I should save that as 102. And obviously I'll try it out before I publish it, but we'll do that, eh? That should be a slight improvement. I might import a 2002 apart and we'll load it onto it and see if it works. Because I've added this other bit here, which I also haven't tested yet, which is the adding a space to the characters here for the numbers. So there's a space between the number and the type of measurement. Added. There we go. Okay. Yeah, I mean, I would be using the last minutes one. Normally I'd use this last minutes and rely on the loop pulling the timing out. But because I don't want to have potential delays, because it is dropping into these other branches and these other functions, so it could cause timing delays. And so I don't want it to be a variable timing or surging. I don't want to sort of have one cycle which is 40 milliseconds, another cycle which is 60, then the next one will be 20. Right, that could happen. So because I want consistent timing, I'm doing it within that loop and wasting a few process cycles, but it's not as efficient this way. But it means the timing be more accurate. If it's something which is less critical in timing, it doesn't really matter. If it's off a bit, then I would definitely use that last minute thing I put in here, which is why I created this. I don't think I actually used it in this sketch, to be honest. I don't think I actually used it anywhere. Let's have a look. Did I even use it anywhere? I've specified it there. I've got it here. That's just for the display updating. Yeah, that's for checking the timer is updated. The actual boot screens. That's the only place I've used it, is for checking the boot screens. So in this case, I haven't actually used it really anyway. Barely at all. Hey Sven, you're doing it in a funny way. Yeah, well, you're here in time. Well, I don't know. I mean, I don't know if it's going to be an issue or not. It's doing 9600 baud, and it gets bytes and builds up the text. So I'm not sure if it's really going to matter anyway. I think I did have some delays. I've got a delay in here. That's for the boot screen. Don't care about that. Let's get rid of that one. I think I did try putting some delays in here. I've got like a 5 millisecond delay here, trying to help between each row is writing in the screen to try and give it a chance to be better. I've got a 5 millisecond there, 5 millisecond there, and a 5 millisecond there. So I do actually have 15 milliseconds within that write. I don't actually know if it made it better or not. I might actually reduce it slightly, make them 3. I put them in there, I didn't really notice a difference. Obviously, a delay is a blocking delay. It doesn't actually allow it to carry on processing. It stops at that point, so it's not very efficient. But I'm just trying to give it time for the display to handle its information that's been sent to it. So it does a print, gives the display some time to deal with it, and then goes on to the next bit. So that's why I've done that. I was actually tempted to actually put delays in between each bit. So it's a set font, then wait 1 millisecond, a set cursor, wait 1 millisecond, kind of thing, I was tempted to do that. just to give it time to process each command that's being sent. I was tempted, but yeah, I said I put those 5 millisecond delays in there. I didn't really see much of a change, so I don't know if it really matters. Anyway, we'll see what happens. I've got a 40 millisecond delay there, so that may or may not help. If it is a slightly longer delay than it's supposed to be, then it may not even matter. I mean, this is, in theory, is 25 frames. I've got that right, haven't I? Yeah, it'd be 25 frames a second, which is still really fast. So if it is longer than that, it's going to be fine, I think. I just don't trying to go too fast, because otherwise it'll potentially be a problem. Anyway, so that's that. So I'll make this available. I'll put this on my GitHub, and once I've tested it, I'll actually test it. So there's 2 things I need to test, which is the that spacing, which I'm confident works. Where did I put that in? That's in... I'll show you it once I find it. It's in here. What did I do for that? Yeah, this bit here. That's that piece I did in for that. So it looks for specific characters. It looks for anything which is a number, basically. So it's a number. And the last thing is like a character or some other special or thing above 41 hex. Assumes it's a special character or something like that. So there's no space there. Then it will add a space onto that text before writing that into it. So it should automatically do it. It should be fairly robust. The only thing I think it might come up on some of the menus where you're setting the time, which I think it shows at the middle section. It might put a space before the colon. So things like that. So that might have a little glitch there, but that'd be easy enough to check the colon character and ignore it for that. I haven't done that, but so I should test this anyway. But I did push it with this code without testing it, to be honest. So I thought if someone doesn't like that, they'll find it and they'll tell me. But no one said anything, so I don't know. Yeah, you get it working first, definitely. I mean, it is obviously functional. It's the code does work. It's just finessing these finer points of it. As you always get, you always go through and you release it, and then someone will find something and you fix that, or someone else will fix that in that case. So you need to do a display file 33220A. I'm not familiar with that device. You can probably adapt it as long as it's just serial communication. I mean, the serial part is also got this part here, which is checking for some serial. That's states. This is getting flags. This is for the flags across the top of the screen. It's using a byte structure. It basically turns it from a hex value into a binary or decimal value, and then what I do is to break that. This is the way I do it anyway. I find it simpler from the way I think, probably because I'm simple. But if you get the byte and then you turn it to a decimal, and then deduct from each bit, right? So I'm doing 127 as the first bit. Then I take that off, and then it leaves me with whatever's left. And then if it's greater than that number, that's the next bit's set. And if it's great, take that off, and then if it's greater than that number, that bit's set, and so on. And so you just deduct it off each time. You go step down, it tells you all the bits. There's probably a better way of doing it, bit shifting or whatever. I find that stuff complicated. I don't like that. I like to do it this way because it's all structured. You can see exactly what you're dealing with. It's easy to understand. So I always do it that way. It's probably a bit of a convoluted way of doing it, but that's the way I do it. And display screen here is then dealing with the characters that come in. So as long as you're doing that initial conversion, this is getting it 1 byte at a time, handling each byte. So and it's checking previous bytes to try and work out whether it's a display screen or character, whatever. So it tracks the 2 previous bytes as well as the current one. So it's 3 bytes it's looking at depending on what it's doing. So there are some places where it's looking at more than 1 byte. somewhere in here. You got last incoming here, and incoming. It's doing a check here. If it knows it's finished doing all the bytes for that screen, for that particular screen view, then it will do a display, which then tries to send it to the display to send it to actually show you what it's looking at. So it waits until it gets to the end, and then does that. So yeah, I mean it's adaptable. Anyway, that's that bit. We don't really be doing code the whole time, do we? Let's do something else. But yeah, it's on my GitHub. If anyone wants to grab it and play with it and put it on their units, and obviously you need a Qualia board for this. Or Qualia? I don't know, it's Qualia. I don't know how you pronounce it. I've been called it Qualia, but it could be Qualia. I don't know. But you know, one of those added through. So it's $20 for the board, $20 for the display, and US, which isn't that bad. And you can have a play with it. You just literally, you don't even have to take your unit apart. Really, you can just take the covers off and program onto R603, and yeah, you can actually play with it without, like I was doing in my video. It was easy to do. I just soldered a resistor onto it, and probe from that. Just make sure you don't shove more than 5 volts into your board. That's all. Hey Patrick, how's it going? Superpass, yeah. Head coding. What, years ago? Oh yeah. Yeah, that's been broken for ages. I finally got into fixing it. One of the actual LEDs had failed in the middle of the string, and so I took it off and swapped it with the one that's on the end of the string. You'll see the very end one there is missing, because I had to replace one over here somewhere. It's about there somewhere. I think it's from the flexing or something that must have affected it. I don't know, but it get data up to that point because it's a serial communication one. What are they called? I've forgotten what they are. Got what the part number's called now. And so I guess at that point, his data's getting munted after that. He's just doing weird stuff after that. So fixed it again. I think it's just like a demo sketch from the Arduino IDE, and then I modified a couple of bits there, and just to make it a bit more interesting. All right. I mean, programming, Arduino IDE, I only started playing with that probably 15 years ago, maybe not even that. Probably less than that, actually. Yeah, probably 10 years ago, probably when I started playing around with it a little bit more. Oh, it could be 15. I did some CB radio conversions using Arduinos. I was basically putting binary in and doing conversions. Use a Pro Mini and stuff like that, I think it was. But yeah, I've done a bit of it probably 15 years ago. I started playing with it, and so it's been a little while. But I don't use it all the time. It's just occasionally I might do some work in it, like this particular project where I wanted to use it. So ESP32s I've used a fair bit for the projects I use for the events I work at. So I've shown those in videos for the results system stuff, and I built all those. So I'm familiar with those things. I actually have an issue. Actually, I want to sit in right here. I've got to fix it. This equipment which I built before, which I showed videos about, if I try and update it on this computer system with the latest version of the Arduino IDE, it will kind of work, but it will crash. Like, it'll be in use for a couple of hours, and then it will crash. And so, for me, that's no good, because it has to be 100% reliable. And so, I don't know why it's doing that yet. I mean, I'm using strings in it. Maybe it's something to do with the way it's doing string handling. I know strings aren't really good to be using, but it was just what fit best. And I've got a few of them in here, and string arrays, which is even worse. So it could be memory leak stuff going on. But it's weird that the old IDE with original library stuff like that, I wasn't getting this issue. But when I'm using a more recent library and a more recent IDE, I'm getting issues. There's obviously something different in the way it's compiling it and handling it. It's puzzling. So that's how I want to try and figure out. But I want to try and bring it up to the latest standards. So I'm using the latest IDE, the latest libraries, and bring it all up, because this stuff is based on versions from 2019, 2020, around there. So 6 years old, basically, is when the libraries and stuff were used, which work reliably. And since then, it's not been so good. So I kind of need to do updates, and I need to get it work properly on the modern system. So that's being troubling. I need to work on that. I've been meaning to work on that for months, but I haven't got around to it. Play stacking things. Well, yeah, well, it's temporary. That stack of equipment there is because my wife wasn't happy about where they were, quite rightly so. They were somewhere else, but they got moved because they were in the way, and then I've moved them again because they're in the way, and now they're over there because the wife's not currently using that desk. She's not using it today, so I thought bring them in here, put them there, and then if we decide to get onto them, at least we've got a few choices there of things we could look at. So anyway, we'll look at the code. I've done a tweak of that. I'll look at that later on. We'll look at this thing first that I'm going to try and repair, fingers crossed, and then if we get through that, maybe I'll pull my 2002 back down again, update the firmware on that with this latest version, and then we can see how that works. If it works, we could do that, and play with that a little bit and just test it out. I'm tempted to do it now, to be honest. I'm tempted to try that before we do the repair. What do you reckon? Should we play with the 2002 first, to that display code, or should we start on a repair and look at the 2002 after? Opinions. Hey Mike, you're wearing that shirt, cool. So yeah, what do you want to do? Do we want to try the updated code on a 2002 right now? Or do we go into the next repair? I'll put it lined up. 2002 first. You just want to see if I broke the code, eh? Okay, here we go. We've got 2 votes for 2002. Let's get the 2002 down and we'll see if it works. Let's do that. I've got to get off the stack first. That's the first challenge. Oh no, I'm wrecking the place now. Ruining the illusion. Just change cameras. Why's my thing not working? And let's go to. Let's get the HDMI camera running. Let's change to this. Once it wakes up. Yeah, it's a bit dim. I haven't turned the other lights on yet. Let's do it with this lighting for now. Ambient lighting. There is some extra lighting. I do have the overhead light on. So the offset there is what's bogging me a little bit. I want it to be over here. That's one of the things that's bugging me a little bit. But I mean, you can see it's working alright. Yeah, so it does look nice. And when I did that video, when I published it, I was thinking, it actually looks a bit dim on screen. You know, on the video, it doesn't really show it in its true brightness. So this is kind of a better representation of what it actually looks like. What you're seeing now with this lighting, you know, it looks fairly bright. And that's kind of what it does actually look like. So it looked a bit dim in that video. So it's not actually bad that it appeared in there for that. This is more realistic. So anyway, let's take it apart. I suppose I should turn the lights on so you can see what I'm doing better. Here we go. So I was very tempted to write in code to do over-the-air updates. It's certainly something I could do, but then you need to access the system to actually do it, which means I'll probably have to have Wi-Fi running on it. I didn't want to do that. I didn't want to have Wi-Fi running. But I've done over-the-air updates on other stuff I've got with ESP32. And so, in that way, it's really convenient. So the over-the-air updates means you just go into menu, say over-the-air update, and it pulls the bloody the bin file off the website. So I've uploaded the bin file to the website, and then bang, there it is. So, you know, it could even mean I could do like updates for other people if they were hooked into their internet systems. Obviously, you don't need to do that. But yeah, so it's something I kind of thinking that yeah, I kind of need to do that. But in reality, is it really going to be needed? Probably not. Only initially, whilst it's being developed. And once it's developed and got the little bugs and stuff out of it, I ain't going to need it anymore, is it? So I thought, well, it's probably not worth worrying about. So I haven't bothered with it. Come on, unhook. I'm worried about breaking one of these things off when I'm doing this. Alright. Now, I think I'm going to unplug all those cables. So I am. These wires aren't quite long enough to be able to remove the front panel out. Yes, I'll reach. Get a cable, plug this thing in. And I'll chat again. So actually I've done it on my laptop. My tablet set up for doing chat over here. I need to go and get that. I did cross my mind earlier on, but I forgot all about it. So when I plug this in, the screen will turn on. Because it's powered. It actually powers up this as well. It actually runs all the 5-volt stuff off this as well, because it's tied together. It's probably not a good thing. It'll give an error right now. Like right now, I'll show you. I hope you can see it on the screen. It's going to give an error. See? Because it's actually the 5-volt system on this is booted up as well. Alright, start this programming. Okay, make sure we've got the right information. Got the right board. Choose the port. Right, let's upload it. And then we'll see if the changes I've done have broken anything. If it works, I can push it to the GitHub later on. I'll do it now. I haven't really used GitHub at all. I mean, obviously I've got code from there and downloaded stuff from GitHub loads of times, but I haven't actually put my own information up there before. So it's like, that's my first project to be put on GitHub. Right, that's programmed. Let's try and manipulate this around. Let's do it some way. Come on, let's do it like this. Yeah, do that. That'll work. Okay. And of course, we've got reflections everywhere. Where's the boot screens? Why did it break? Oh, I know why it broke. I've done something silly. Okay. This is why I test these things. I don't have it initially set in that number, so it doesn't never actually updates the display. Let's fix that. Right, so what I've done, like an idiot, that cannot be more than that because it's not been set yet. So initially it's not set. I should be doing less than, not more than. Shouldn't I? Right, so if that timer is less than millis, so the time's elapsed, that's what I should be doing. That is correct. That should fix it. No, it's not affecting calibration at all. It's only purely display. That's all it's doing. Okay, it's rebooting. Right, let's go and check, see if it actually did anything. They should fix that, hopefully. Yeah. Right, let's try this again. Yay, look at that. It helps you put the correct symbol in, doesn't it? There you go. There's the space. Space is in there now. Excellent, that's working. Just going to try and watch it for a second, see if I can see any glitches on display with that. Yeah, I'm seeing a little bit there on the D. D's flicking a little bit sometimes. Let's change the update rate. So you can see that, maybe you can see it there, that little glitching across here, just a little bit. That's what I'm seeing. That's the worst thing I'm seeing, is like this little flicker on them. That's all I'm getting, right? I haven't seen anything worse than that. So I don't know if it's to do with the fact that I'm writing a background on it as well, and maybe it's to do with overwriting, or it could be a timing thing still. I mean, it's still fairly fast. But it's very subtle, but it is there. I would like to get rid of that. Then we could try putting a longer delay in and see if it does solve it. I mean, it's still doing 25 frames, which is still pretty quick. So we could try dropping it down a bit more. I think we'll try doing that a bit faster, a bit slower. We'll try that. Let's plug this in again. Let's go down to, let's halve it. Let's make it 80 milliseconds and see if that helps. Okay, it's got 80 here. So that should be half as fast an update rate. Should be. Let's program that. Fixed with timing. So you reckon it's those front porch, back porch stuff up here? In this original Arduino code where I've lost it. Where is it? There. Do you reckon it's that that's causing the problem? We'll try this anyway. I mean, it's done. It's already uploaded the code. We'll see if this. I mean, as long as the update rate's still fast enough for you to read it, it's fine. You want to obviously see that it is legitimate, but having a 25 frames update rate is still pretty quick. All right, like that, and change screen so you can see what I'm doing. Because that'd be silly otherwise. All right, let's try this. I'll change the speed again because it doesn't input on power up. Doesn't use the last few settings, unfortunately. So configure, DC volts, speed, fast. Yeah, it's still there. And you can see the update rate is still plenty fast enough. So you reckon I need to change those other timings to you, Ian? That's causing it. Writing to drive when we're ready. Okay, right. So yeah, so you probably, so I could still be writing to it too quickly then. What I might do then is put some delays in here, because I was thinking about doing this anyway, and as I have this massive delay at the bottom here, which doesn't seem to have a big negative impact, what I might do then is after each command just give it a second, or a millisecond. We'll do that. Give it 1 millisecond after each command, just to give it a chance to process each command before it tries to do the next thing. Yes, it's blocking. You know, it's not ideal. I'll try doing this, and just in case that is enough breathing room. Yeah, stick that there. It is not exactly a wonderful way of doing it, but yeah, it will do it. I'll leave that 3 there, I think. 3 there, 3 there, yeah, I'll leave those there. And we'll see if that helps at all. Just to give it some breathing space between commands. That shouldn't be needed there. I missed that one. Six milliseconds between sends. Wow, okay. But we'll see. We'll see. I'll try this first. I mean, it's still giving it a little bit of breathing space. It might be enough. I want to keep it as small as possible, obviously. Let's do this one, send this to it. And I could actually keep this cable plugged in while I'm doing this testing. It doesn't actually matter, but this means I have to keep pushing the reset button on the unit when I try and test it. I'd rather just unplug the cable. Right, let's upload that. We'll try this one. These little delays in there. I think I missed any. That'll be covered by that. As will that one. So, as will that one. So I probably didn't actually need that one there. That one there didn't need to be there. That can go. Right. Okay, let's try it again. Come on. No, it's still getting it. And you see the update rate, it's still fine. It's still really fast. So, it's not an issue. I'll give it some more. You reckon 6 milliseconds. Let's try going 5. Let's try going 5. I mean, it's only testing anyway. That's all we're doing, isn't it? So, it's going to slow it down a fair bit, putting 5 between each one, but it may not matter based on how quickly it's updating anyway. It's taking longer to play with than I thought, but it's alright. 5. What I might do here is actually go like this, and where's the replace on this thing? So do find it doesn't have find and replace. Replace with files? I don't know. Oh, I was going to do that, but it's not going to work in here. Not what I wanted. Okay. I've got some other software I'm going to do find and replace really easily. Just do a search for it and it does it. But that's fine. Let's do it this way. It's a bit longer, so it's probably a better way of doing this. Oops, 15. Oh, 5. Let's try. So I mean, it would be nice to get rid of this little glitching away, you know, because I want to get it so it's perfect if I can. And if it's a simple fix, you know, it just makes sense to do it, doesn't it? Stick a 5 in there as well. Obviously, it's definitely going to slow the display down, but it may not matter. And it is blocking, so. I mean, it's impossible it's done to a damn thing. It might actually be fixing the problem. It might be something else which is causing that glitching. It may not be a timing problem. It might be something else. It's entirely possible it's something else. Just be nice to figure that out. I'm going to leave that as there, as 80. Let's upload that. I mean, it might be a case of just finding what timing works. I mean, if 5 works, then I'll try going maybe 4 and then 3 and just find the fastest one. And because you obviously do want it to be nice and quick, but as you can see on the screen, it's plenty fast enough. But having all these delays in here, it's going to be adding up in it. You know, there's 20 milliseconds there, another 20 there, another 20 there, 20 there. So that's already 80 there. There's 100 milliseconds there, so it's like that's going to be 10 times a second update rate, effectively. Although I update each line, so it's not going to look like 100. Yeah, it's not going to look like 100 milliseconds because it's doing each line at a time. So each line will update every 100 milliseconds. Well, with the 180 milliseconds. but the overall display is, yeah, we'll see. Let's try it. Okay, configure, DC, speed, fast. Still seeing a little bit. Still there. And that looks faster than 100 milliseconds, doesn't it? Or is it? I don't know, maybe. That looks faster than 100 milliseconds. That update rate's faster than I thought it'd be. The glitching's still there, but it's slower. Before it'd like ripple across, and now it's like bang, 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 bang. You can see it appear on each one, and then move across. It is better, but it may not be timing, it might be something else. I mean, to me, that although it's looking better, I think it's looking better because it's happening less frequently because it's running slower. I don't think it's actually made a difference, to be honest. Anyway, it's a little experiment. I might speed it back up again and just leave it as it is for the time being and play with it some other time. Maybe someone else can figure this out when they do theirs. I don't know. But because I'm writing to the background, doing all these little workarounds and these little, I suppose you could say they're hacks, what I'm doing, where it's got to overwrite the background in black. So when I'm doing this, so you don't get artifacts of the previous line. So if this line's that long, I go to say temperature, which is shorter or something. Yeah, set shorter. So it wouldn't have that text sitting there still. It has to override with a whole bunch of spaces at the back of it. So because I'm writing spaces with black backgrounds, I think it's causing those glitches. Even on this one here, I'm getting glitches a little bit. Yeah, see, they're just there. So it's not perfect even with a short display. But it does seem to mostly be around update rate. The faster it updates, the more obvious it is. And even this one here is updating relatively slowly. I'm still seeing glitches over here. I'm seeing a little one just there flickering. So, yeah, I'm not sure. But even with those delays in there, that's still not a bad update rate, even at the fastest speed. I mean, obviously, it's definitely visibly slower. Yeah. It may be the way the data's being written to the string, which is being pushed to the display. It could even be that some kind of glitch in there. Maybe there's a bit of information or something, which is a bit dodgy. Could be dodgy bits getting through, which is causing confusion. That's also possible. Because I'm not catching all the bits, or each byte. There are some bytes there which are random and not necessarily filtered out, which shouldn't be there. Maybe those bytes are getting through and the display's trying to handle them and it doesn't know what to do with it. It kind of does something. I don't know. It's possible. Anyway, at least I know the spacing code worked. I wanted to prove that at the very least, and that's working. So if I go into, say, menu, go to the menu, there we go. So I want to find something which has got, where we go, let's go here, calibration, it's in there. Dates, view, okay, that's a spine, okay. That's okay. What's the other thing I'm looking for? General. It's not a general. That's right. Let's look in there. That looks alright. I was trying to see if there's anything in here which will get screwed up. That looks alright. By having that space shoved in there, you know. That looks alright. Timestamp. That looks alright. Clock. Time set. Okay, that's coming up right. This one I was thinking might be an issue where it's got the colons in there, but that's coming out fine as well. I'm actually looking to see what the decimal hex conversion is for that actually. So maybe that's below that 41 hex. So that's why it's fine. That's what I was kind of thinking. I haven't actually checked. I thought it would be, but that's okay. Yeah, so I'm fairly happy with that. Actually, I'm happy with that. So okay. I'm going to strip that code back down again to speed it back up because it hasn't actually solved the issue. Something else must be going on there. But as you can see, it is working otherwise perfectly fine. It's just that little flicker on there, which isn't even that noticeable. You know, it's just a little bit. Yeah. So let's take that back out again. And I'll upload the code as it is with this, without these delays in there. I'll leave that 5 one there. That's not doing any harm. I'll just take these ones out. I'll leave it after each does a. Yeah, hold on. Might leave that one there. I think I'll leave one after a right. After it does a right, I might leave that one in. Yeah, that's right. That's what I had before. But changing parameters, I had no delays on those before. Let's read the text down here, some comments. Yeah, the chip's programmed because it's programmed over USB. So that particular device, that board has got in there, it's a Adafruit Quila or Qualia board, I don't know how you pronounce it, and it's got a USB-C port on it. And the Arduino IDE just sets that port. You plug it in over USB. You choose the port from up here. In this section here, you choose the port which comes up for that particular board when it's plugged in. It's not plugged in right now, and then this program over there dumps it over USB. Not all chips have USB support, but these ESP32s do, and so you program over USB. It's pretty simple that way. I don't think there's anything else I could possibly do. And this is the code I'm using here for doing that spacing. So it's a bit of a hack. I don't actually like what I've done here. It's because of the spacing on the font. If the font was monospace, which is one of the things I don't like about it. It's a nice font, but it's not monospace, and so the spaces themselves are narrower than a character, or narrow characters are narrower than a wider character, right? So monospace would be better for it. So what I'm doing is for spaces, I'm actually checking to see how many there are, and adds extra ones in. So for each space it finds, it adds in 3, I think it is. Yeah, adds 3 spaces for each one it finds to try and make them wider. So if it finds a string with 10 spaces in it, it'll add in 30 spaces to try and pad it right out to fill the screen up. And this could be part of the issue it's got with the flicker. It's possible. It could be something to do with that and the way it's not quite translating nicely. It's possible. Or it could even be the way it's actually compiling the string and then sending a string. It could be sending a partial string and then sending a full string. That's possible as well. and so that's what's causing the flicker, because it's a bit shorter than it should be, then it fills it in. Maybe I've got an issue with that, I don't know. I might have to look at this in more detail, but anyway, let's plug this thing in. Oh, I missed some there. And then program it again with these files at times. I'll leave that, I might leave that one there as faulty. I might leave that there. Give some kind of delay for it, but give it some breathing room. And I'll leave the rest as it is. Yeah. Let's plug this back in again and reprogram it. But I'm pretty happy with it. It works well enough for me. I'm you know, it's just finessing it a little bit and just trying to get it a little bit better. You know, it's just, I would like to get it perfect. So that's the ultimate game. It's like it works properly, you know, and it does work. It's not perfect, and I'd like to get it perfect. So, all right, the port should show up now. Port is there. Yeah. Upload it. Let's carry on reading the comments here. Okay, right. Could be the serial data. Yeah, I've seen delays in serial data. It isn't consistent. It does hesitate. You can actually see it in that video I did where it's updating the screen. I think I had the red TFT on there. I think it showed up then. It didn't update, paused, then did another update. So it wasn't actually consistent update speed. You even saw it on the VFD. It didn't update straight away. So it could be little things like that where there is timing coming from the actual unit which is causing issues. Anyway, number shifts a bit in VDC. Yeah, it does. The VDC one's jumping around a little bit because of the sometimes because it's just floating. Sometimes it's not millivolts, it's just volts. So it jumps left a bit when there's no millivolts. So, you know, that's happening. It could be something with that. Could be the string length changing. I mean, I'm suspicious about that. But yeah, I mean, it's not perfect, but it works. And that's the main thing. It's better than a display which is barely readable. So, but it's one of the things which is going to bug me, I'm sure, and I will end up getting to the bottom of it if somebody else doesn't get to the bottom of it before me. I'm hoping someone does get to the bottom of it before me because I don't have to do it. It could be something simple. I've probably written something in a way which doesn't quite translate well. It could be something which is not done well. It's entirely possible. Where I did originally in where was it? I'll show you what I'm suspecting. Tell me where it is. No, not in there. Where is it? This one. I did actually have this as an if, not a while. And having an if was way more glitchy. I was trying to do it like byte by byte. So I grabbed each byte, processed it, came back, got the next byte. I was trying to do it in a nice sequential manner. And then I found that it was troublesome. But running it a while, which is why I've still got here as commented out, running a while instead, I found was more reliable. So I've run it as a while, which in theory, it kind of should be okay, but maybe the fact that there's a difference between the two is highlighting there's some edge case there which isn't quite handled right. It could be related to that. That's in mind anyway. So anyway, that's programmed again so I can put everything back together and we'll move on to doing something else. But at least I know that spacing code is working correctly and it's not causing any other issues, at least no obvious ones that I can see. So I'm happy enough with that. So I'll push this to GitHub later on. when float to string conversion. I'm not using any floats. I'm not using any floats at all. I don't like using floats if I can avoid it. I'm using either chars or strings or hex. Yeah. Although there is decimal conversion there too for the flags to do that calculation stuff. Yeah. Okay, right, let's put this one back together. Then we'll work on the thing which I actually intend to work on, hopefully. Which is a similar thing. Very similar. Right. I suppose I should do one more test before I actually reassemble it, just to be absolutely sure it's not screwed up now. But yeah, that's what bugs me the most, is that is offset, not in the middle. But that's purely because of the spaces. I was actually tempted to pad it on the boot screen. I thought, oh, no, I'll leave it. Because someone changed the font, ended up shoving theirs over. So I thought I'd just leave it as it is. But anyway, I'm happy enough with that. That looks okay. Just those little glitches occasionally. I mean, just it's barely even noticeable. I think it's because I'm sort of looking at it in an analytical way. You know, what's wrong with it, sort of thing, rather than just using it. If you were just using it, you probably wouldn't notice. But yeah. Anyway, right, let's put this thing back together. And as mentioned before, yes, it's a massive dash chip. I think I did cover that in the video, didn't I? I did the 2002 repair. Yeah, I did a repair on this thing. I did mention that. I did the upgrade on it. Replaced that Dallas RAM. I've got the original one still sitting here. Over here somewhere. Who is it? I've got a few of these sitting around now. I have about 4 of them. I've been doing a few Dallas RAM things recently, it seems. So 3 of these are from the HP 3458A, and that one is from this. Yeah. Yeah. 1230s, 1220. I don't know. It's half tempting to try and open these things up and replace the batteries in them. Because these things are so bloody expensive. That's over $100. These ones here are about $50 each. I don't know what that one is. Just the prices are horrendous. Anyway. Surprised this camera's not gone to sleep yet. Must be getting close. Let's put this thing back together and try and get it back in. Got to try and get that tucked around. Out through. Got to try and get the power button to run through now. Okay. If nothing's sitting weird. That's right. Yes, I spent way too much money this year on precision multimeters. I spent, what did I spend on this thing? I think I spent, this is like 4,500 for this thing as a broken unit. I think it's 4,500. Was it 5,000? Something like that anyway. It's worth a lot more now, but that doesn't matter because I'm not selling it. Its value is only relevant if you're actually going to sell it, and I'm not. I purchased it to keep it, so that value doesn't matter. And I've got the 23458As. Got one at the end of last year, and a second one this year. So yeah, those weren't cheap. One was 7,500. The other one was, I think it was about, what did I pay for the second one? I think I paid about 4,000 for the second one. So yeah, I spent way too much money this year on precision multimeters. It's just a bit ridiculous. But out of that, I've got 2.5 digit multimeters which work, and one which will work eventually. Hopefully. It's not perfect. Get the right one around. Yeah, so having the supporters for the channel, and that's Patreon supporters and YouTube members. I know some of you here. That really helps because, as I say, a lot more videos. This thing's expensive. This YouTube thing is expensive, and yeah. I mean, I've spent just on 2 of those multimeters is $10,000, right? That'll take me many years of YouTube members and many years of YouTube payments for advertising just to pay for those units. So it takes years and years. I don't get that much money. So all the money I do get from YouTube goes back into it by buying test gear. Anyway, that's that back together. We'll put this back on the shelf and we'll start on the next thing. Right. You're going to get a slight sense of deja vu here, because this is the next thing. I need to go and get my tablet so I can see the chat while I'm on my desk. Back a minute. Convenient sneeze whilst I wasn't in the room. That's useful. Right, let's get the tablet turned on. And I think I need to run those. Yeah, hold on. I might just mute the audio for a second. Okay. Tablet should be booted by now. It probably wants to do 500 updates because I haven't turned the thing on for about a month. Come on, wake up. Slowly getting there. So I'm going to come to the stream and then just look at the chat. Here we go. Right, chat's here. Get my thing here set up as well. Is this MU fixed yet? No. I haven't touched it in like 6 weeks, 2 months. It's still sitting here. I haven't touched it. I've been doing other stuff. Right. And it's all catching up, of course it is. Right, let's plug power into this thing, keep it charging. Which is on the bottom. Of course it's on the bottom. Oh dear. I'm going to wreck the place now. Drop the thing. It's alright, if it breaks I can fix it. How don't we go there? Okay. Right, this thing here. Now I want to do a video about this as well. So let's get the video set up and we'll go from there. Right, so I'm looking at this thing right now, which is a Keysight 2001. I showed this in a mailbag previously, and it needs some repairs done to it. So that's what we're going to try and do today. It's failing self-test and also calibration. It's giving a few errors, but it's got an error mentioned up here. But yeah, it's been rejected apparently. So that's fine. It may or may not be an easy repair. I'm hoping it is. So let's just pair it up and I'll quickly recap what we're getting. And we'll go from there. So it's 2001M, so it's a newer model. So the calibration was due 5 years ago, and as you can see, it is working. And if I want to do more digits, I can. Just configure that to high resolution, which only work until the next power cycle, because it doesn't save it, unfortunately. These buttons are a little bit dirty. What are you doing? 7.5 digits. Okay, back out again. There we go. So, and as you can see, the display is actually looking really nice. Display's good. So, I actually purchased this thinking that if it's really bad, I could use the display in this in my 2002. But since then, I've done the TFT upgrade on it. I no longer need to put a new display in it. Now, this was about, I think it was about $1,000 in Zealand. I think that's what I paid for this. I got that thinking if I only salvage the display and put that in my 2002, that it's still faster, still cheaper than me buying just the display for my 2002. Keysight wanted $2,000 in Zealand for a brand new display assembly, which is obviously the display and the PCB it's on. I didn't want to spend that kind of money. So, yeah, I thought if I spend half as much and get an entire unit, worst case, I can fix the entire unit and sell it again and get money back. Or I could take the display out, put it in my unit, and I've saved $1,000. And I've got a parts unit, you know. So that's what I've gone with. Anyway, it's here. As you can see, it's powered up. It is kind of working. It does actually work on DC volts, AC volts, stuff like that. I think it does AC volts. I haven't tried that. But it's failing self-test. I did show this mailbag, and a bit of a spoiler for my current viewers which are watching via the live stream, because I'm doing a live stream right now, and that is that this hasn't been seen by them yet. It's a bit of a surprise. This comes out in a future mailbag, but you would have seen this by now when you see this one, if you're watching this in this video. Confusing? Yes, definitely. So let's go into menus and let's do self-test. And I'll show you what's going wrong with it. Apart from the buttons being a bit dodgy. Okay. So tester failed. 309.1, 309.2, 309.5, 309.6, 310.1, which is an interesting one, and 412.1. All to do with amps, something to do with the amp circuitry. And yeah, I've tried injecting amps into it through the amps jack here, and it is reading amps, it is reading something, but it's completely out of whack. Now I showed that in the mailbag video to demonstrate that. So that's what I want to try and figure out today. I want to dig into that and try and solve that problem if we can. Thankfully there are circuit diagrams for this thing. Thankfully. My chat has gone right up here because I fumbled the thing and nearly dropped it. Right. Bench is too shiny. Yeah, it is very shiny. is low noise version. Okay. Right, anyway, so as you can see, it is kind of working, but it has some faults. So I'll take it apart. Oh, let's dismantle this thing. Now, this unit isn't perfect. It's got a few marks on it. I mean, it was really dirty in the eBay listings. It was looking quite bad in the eBay listings. It was looking very dirty and stuff, but they actually cleaned it before they sent it, which is nice. And it's got a missing foot here. But that's not a problem. I actually have a 7001, which I purchased, hopefully to sandwich the screen from that for the 2002. But the screen was only marginally better. It was better, but it was still uneven and aged, so it wasn't worth changing it. Which is a shame, because I purchased that unit basically for that. But it comes with all the feet and the tilting barrel and everything, so I can actually bring this one back up to fully complete once I've finished fixing it. Because I do actually have the necessary bits that bolt back onto it. So that's alright. The literary panel is actually nicer than one of my 2002. I'm actually tempted to swap them. This one's in better condition. I might actually swap it. I'll think about it. Okay. In fact, the casing's probably better too. Maybe I'll swap the whole casing in my 2002. Because it will be the same. The same chassis. Because my 2002 is a bit yellowed and stuff. Yeah. Maybe I'll swap those casings around and put the uglier one on this thing. Because the 2002 is the one I want to have looking nice. That's what I'm definitely going to be keeping. Okay. Let's have a close look in here. So it's similar to the 2002. It's a different analog board. The analog board is not it's not the same analog board as a 2002. Analog to digital board is also different. It's the same form factor, but it's not the same. It's been upgraded. Now, when I took the cover off, you may have noticed, or you may not have noticed, that the plastic shield was not present. This shield here, I already took it out when I looked at it in the mailbag. I didn't bother putting it back in again because I knew I was going to take it apart. So that's why that's not there. So I've had a quick look around. I haven't seen anything wrong. Nothing obvious. So trying to figure out exactly where that fault is going to be interesting. And here's the rear side, which is the digital board. And the difference between this unit and the 2002 is that the 2001 over here has got the VFD driver, 60 volt driver. Now in the 2002 that's not populated, it's on the back of the screen instead, which you would have seen from that video I did, if you looked at the 2002 video. Over here we've got a chip, that's just a standard RAM, SRAM, not memory backed like 2002 had this in it, that SRAM. I upgraded that to, well, replaced it with a brand new one, so it will last another 20 years probably. But this one means it'll remember it whilst it's powered on. Once you power it off, it loses the information like setups and stuff like that. You can set up a boot configuration. This doesn't allow for that particular chip. So upgrading that to a Dallas RAM would be nice, or an FRAM. Now the memory one option is a DS1230Y, which I can upgrade to an FRAM. So that's an option for this. Put an FRAM here, right? You don't have to worry about it ever again. And it will give some options. Give memory 1, not memory 2. So that's a consideration. But like I'm saying, that's the driver, which does 60 volts. It runs through that cable there to the display. So there are some differences between this unit and the 2002, but it's the same PCB for the digital side. Capacitors and stuff like that, they surprisingly look okay. I'm kind of relieved to see they look okay. There's nothing obvious leaked. Now the date codes in here, I think the latest saw was 2008. This has also got B16 memory, so it's version B on here. Yeah, 2008 is like the latest I've seen on some of these chips and stuff. So it's 2008 build, from what I can tell. So it's not too old. But a common problem with these Keithleys is that Ian Johnston will know is here in the live stream. He's had to rebuild all his section once before because he had one of these, and I think that capacitor had leaked and destroyed basically all that circuitry. These often can leak quite badly as well and destroy this circuitry. So it's a common failure point that these caps leak on these models, and they cause all kinds of devastation. Usually repairable, not always, but usually. Thankfully, I haven't seen any signs of leakage whatsoever, but I'm going to replace these caps anyway. It's going to be recapped, so there's no kind of doubt about that or doubt about condition. If it's recapped, that's it, it's done. I don't have to worry about it for another 10 years or longer. I'll probably recap it and then make sure it's all working properly and finish repairing it all. And once it's repaired, I'll probably sell it again. I don't need another 7.5 digit meter. I've got a few of them. I don't need them. I've got some 8.5 digits as well. I've got a Keithley 59 DMM7510 up there, which is a 7.5 digit meter there. So I don't actually need this. I got this thinking I might use it for the display. That's basically why I bought it. I might make a good video for do repair too. So anyway, somewhere in here is a fault with the amps circuitry. So we'll go and look at the circuit diagrams and try and figure out what's going on now. I've already looked at them a little bit, and there's some parts I want to look for. I haven't found them yet. Not sure where they are. I'm actually wondering if they're on the back of the board, because I haven't found them from looking at photos and stuff like that. So there's various photos online, although maybe not this exact version of it, different variants. Earlier variant is what's online. This has got a different setup here, like that resistor there is diagonal. It's a little bit different, slightly different setup. So this is a newer version of it. So anyway, somewhere there's some parts I want to find. Haven't found them yet, and those are the parts I want to test. So they could actually be on the back of the board. But as you've got to take the board out anyway to do recapping, it doesn't matter. We can have a look at that. Yeah, exactly. High voltage detection circuit hill, definitely. Yeah, this is newer than the 2002. This is definitely newer. It's a later version. It looks really good. It's actually really good condition. Yeah. So 7510 is got a very nice user interface, and it's really fast. It's incredibly fast. I really like my one. I really like it. If I didn't have that, then I would keep this as a bench unit. But I do have that, so I don't need this. And my other lab, I don't really need this sort of precision out there. I'm using, what have I got out there? A Fluke 45. That's what I'm using out there. Yeah, using a Fluke 45 out there. So, I mean, I don't know, I could put this one out there. Maybe I'll keep it and sell a Fluke 45. Have a nice unit out there. Oh, mind you, Fluke 45's got continuity on it. Remember rightly? Anyway. So, what we need to do here, this board's got to come out to be recapped, and there's only a few caps on this one. I need to check see if I've got a big enough one actually. 15,000 at 16 volt, 15,000, 25 volt. That'll do. Now, annoyingly, when I recapped the 2002, when I recapped the 2002, I put a whole bunch of capacitors on my shopping cart for DigiKey. Now, because I've been buying a whole bunch of stuff from DigiKey, my budget wasn't enough to cover the cost of buying everything at once. So I prioritised what I was buying, and the capacitors which I put on the shopping cart is I thought was a lower priority. So I haven't purchased those. They're still sitting there as a saved card. So I'm hoping I've got all the parts I need, because that could have been that some of those caps I've ordered or have potential to order are ones I need because I've used them all. It's possible. So I may not be able to do a full recap. We'll see. But I've got that big one there. These other ones here, they should be simple. So we'll do this digital ball first, get that one done. There's also one on the driver here. I should probably do that too. So yeah, I'll do the digital ball first, recap that, and then we'll pull it apart, do this board, recap that one, and whilst that board's out, we'll have a close look at the back, see if we can find those parts which are used in the analog amp circuitry. I believe it'll be analog side which is causing the problem. It could be digital switching. It's entirely possible. It does have some switches in there, and they do fail. Well, it's got an A300A once. Alright. Okay. So with that part, the yellow ones, these ones here, I think one of these was a hard one. Which one was it? One of those was a higher voltage or something like that. And something one of these ones in the 2002, which was a bit tricky. Maybe it's that one. 1000 microfarads, 50 volt. Maybe it's that one. One of them was I was a bit worried about. What I don't like is the usual thing here: capacitor right up against the heatsink. You know, it's like that's just asking for it to fail. You know, again here, these ones here, right up against the heatsinks, right next to them. I mean, I really don't like that. I understand capacitors being close to the power source to get the ripple out of it as quickly as possible, to get a nice clean supply as close to the regulator as possible. I completely understand that. But they could put it 5mm further away or 10mm further away, and it wouldn't really affect the electronics that much, and it would greatly increase the lifespan of capacitors. Stops them getting so hot. Anyway, pet peeve. I've mentioned it many times. So before I touch this board, I'll put gloves on, stuff like that. And this board is a bit of a pain to take out. There's a bit involved getting it out. It's not impossible, but it is a little bit of a pain. And you know, I'm not too worried. But we'll do the digital board first. Then we'll look at trying to. I mean, obviously, ultimately, we've got to fix the amp's fault and go through that process. So let's put this plug here if I can. That's a display pull plug. There's nothing we need to do in here. There's no caps on that board. There's nothing we need to touch. The display is good. I don't have to take the board off at all. That can stay exactly where it is. So they did cram a lot in here. Hey Swantick, how's it going? I'll be back in a second. I'll do something. Right. Drink. Talking a lot makes my throat a bit dry. No, it's not beer. Just one of these things, which are bad for you, but I don't drink many of them. I say that every live stream when I pull one of these things out. Right. I'm going to pull this thing apart now. Look at this. Got to take that rail off there, maybe. Oh, all it is off. That's convenient. Right. That fell off surprisingly easy. I'm surprised by that. Okay. Let's get a bit of camera shot. Hopefully a bit of camera shot. Yeah, it works, I suppose. Right, let's take this thing apart. Now this has already come off. It's basically clips onto the power switch on the back here. And that board is a power switch there. And it sort of pushes onto that. I'm surprised it fell off so easily actually. But that's off already. We've got this connector here, which is for the fan. Pull that out. Got this connector here. This one here. Might need a bit of effort here to get this one out. Okay. It's all pretty straightforward. Getting this board out is the easy one. The other side is the harder one. I believe we've got to take these off as well. Okay. And now, if you think about static electricity, some people probably don't consider it at all. My desk is earthed. This is an anti-static mat, and I'm constantly touching it. Right, and my clothes are cotton, things like that. So I don't wear nylons and things like that. So I don't want to blow things up because of that. So although it looks like I'm just being a bit flippant about it, things are actually covered. If you weren't confident in your earthing, then you'd chuck a wrist strap on. Just do it. I do actually have one here if I'm doing stuff where I'm standing up, moving around, not actually touching the bench. I do use them for that, but because I'm constantly touching the bench, I'm not worried about it. You know, I've got it as a habit that I often rest my hand on the bench. I'm putting parts up and down and things like that. Each time I put a screw down, for example, I'm touching the bench, that sort of stuff. So I'm constantly doing it. I mean, if you're being really, really fussy about it, you're doing something which is super sensitive, then you just put a strap on. I should rephrase that. Put a wrist strap on. Let's get tweezer. Is that all of them? Still doesn't want to move yet. Maybe it's that one there as well. I think it might be. I'm not sure. That's moving. It's not moving, but I'm not seeing any more screws. I had this problem before when I did the 2002. It was kind of stuck, but you don't want to force it. You want to just double check to make sure you haven't missed anything. That's moving there. That's moving there. That's moving at the back there. Is it that? Ah, it's that one there. That's what I missed. This one here. And that's the wrong size. Okay, let's get a driver for that. Wrecking the place in the meantime. What size is that thing? What, that one? Not that one. Yeah, between those two. That one. Okay. It's really there. That moves there. Yeah, the whole bird's moving now. This slides down, but I think I gotta be careful about catching on stuff. It slides so far, then it lifts out. It's still not happy. It's moving so far. Not quite sure what's making it drag. It might just be tight. That's not in the way. That's not in the way. I think it's just tight. I'm definitely not missing something in the back, am I? No, there's nothing there. Okay. Remember this? Yeah, when I did the 2002, it was just tight. Why is it not wanting to move further than that, though? I don't see it hitting on anything. I'll let you know what I find when I finish recording. I wasn't wasting my time watching this. Where the hell is it? What's making that tight? The front's free. As free as it gets. The back is free. Feels like something around here. there's definitely nothing on the other side, alright? There's nothing there. Just wondering why it's... I don't remember it being like this when I pulled the other one out on the 2002. It's just... It was tight, but then it freed up. It feels like something's stopping it. I'll slide it back again. If I can. Okay, slip back and slide it forward again. Yeah, it's just like... It moves freely, then it stops. It's almost like that D-sub there is hitting something. Maybe it's that fan wire. Maybe it's the fan wire is getting caught up on it or something, because it is in that region. Okay, well, it's just tinkering with it. Just something just there making it stop. When I got this frame here was bent. It was actually bent outwards a little bit. I straightened it up and I pulled the thing apart. So maybe it's had an impact which has shifted something. And this is not in the way. It's not that bit that's causing the problem. Yeah, it could be something which is making it not sit quite right. I mean, there to there is sliding fine, right? But I'll get to there, and that kind of wants to lift a little bit. I think something's shifted. The wire for the fan is right there, right? It's just a bit strange. Back panel can't be removed. It's a folded piece of aluminium. It's one piece. It does slide out. This is how it comes out. I did it on the 2002, and it's exactly the same chassis. It's identical. But and that one originally it was like jammed, and then once it unjammed, it moved fine. It was sliding freely, and this is also sliding freely up to a point, and then it suddenly stops. Okay, I got it there. I lifted the D-sub up. So yeah, I don't know why that was hitting. That wasn't a fan, I don't think. The fan wire is right there. Maybe could have been a fan wire actually. It could have been. That is kind of where these are. They could have been that rubbing on the fan wire. Right, I think that's what it was. So the wire for the fan is coming up in the back here. So we can see it just there. And that I think is what's causing the problem. That is in the way, and it's getting caught on the back of this, and so it's trying to jam it. So once I lifted it a little bit to get it over that wire, then I was able to slide it out. But yeah, I think that wire's in the wrong place. Yeah, I'm pretty sure that's what it is. That fan wire is sitting in the wrong place. Yeah, I think that's what it was. Okay. Let's rekit this thing. So I've got, definitely have to get some more of them. That's the last one. What else do I do here? Apart from my glasses so I can read stuff close. Getting old, man. Right. 47 to 35. 1016. 1016. And I've got this module here, which I kind of need to do as well. Now I have to take the module off to do it, which is a bit of a pain. That's a 250 volt cap, 1 microfarad 250 volt. Right, that one might be trouble. So we want 47 at, what did I say I want? 50 volt, right? 35. Yeah, 47, 35. And we want 1000. I've got 25s here. I think these are some of the ones I was going to buy, or some 16s. Yeah, I think that's some I was going to buy because they're physically smaller. Alright. Is that the same? Yeah. So that's those 4. Don't think I can do that one. I don't think I've got one. 1 microfarad at 250 volt. It might get lucky, you never know. Oh, I've got 450, but it's physically a lot larger. 1 microfarad at 250 volt. Look at that. Also physically a lot larger, but I don't think it'd be a problem. Good one. Like you have the right parts. That's nice. You got one sitting on there as well, waiting to be fixed. Cool. Right. What's wrong with it? Do you know yet? Or have you not investigated it all yet? Okay. Let's start the easy ones. Let's get my USB-C cable out of the way. Don't need that now. I'm going to melt it this time around, really. So I've got the caps out that I need here. I've got the 15,000. I've got 1000s. That's 25 volts instead of 16. I've got a 1 microfarad at 200. 1 microfarad at 250 volt, which is what's on that driver board here, although it's physically a lot smaller. This one's a bigger cap. The hub is going to be trying to get that one. I might take the whole driver board off to get to that one. And then we've got a 47 to 35. So that's what the caps we need for this board. So I'll do that one first because that's the oddball. That's the oddball one, and then the other ones will be easier. So always make a note of the polarities. Negative that way, negatives that way, and that way. Often there's a square pad like that one, so it gives you an indication. And always, it's a good idea to check them before you start to make sure they're all the same. I've come across them being wrong before. Square pads are positive. Sometimes they're not, and it pays to check just in case it's been done wrong. But those look okay. So let's desolder these. First thing I'll do is put some fresh solder on. Just makes it easier to get it off. Let me just put my extractor on, get rid of the fumes. Now sometimes the easiest way of doing this, actually my iron's a bit cold for this board, needs a bit more heat. Sometimes the easiest way of doing this is just to heat them up and take the part out, and then clear the holes afterwards. Let's just see, here we go. Depends on the board. Sometimes it's easier to walk them out, other times it's not. This one's being a bit stubborn. Thermals are being a problem. That is not moving at all yet. There we go, there goes one. Yeah, this board's thermals are pretty strong. It's not going through the board at all. Here we go, there goes the other one. Yeah. Okay, that took a bit to get that one out. Might even need more heat than that. Okay, let's clear the holes out. Yeah, one of them's not done. Because it's got a big ground plane there, or power plane, one or the other. That's still being a problem. That's why it's hard to desolder. The analog board's easier. The power plane is not so much of an issue on that one, but this digital board is a bit of a problem for that. Okay. So that's this one here, it's 47 microfarad. Get the polarity right around. Actually, let's clean this up a little bit. So there's a bit of flux on that side from cleaning it, from desoldering. Get the mess off while I still can. Did pick up the right cap, didn't I? Double check that. Yep. Next ones. Now you get the idea. I'm not going to record every single one of them. Don't remember what's wrong with it. You should probably get it out there and have a look. I saw you doing your KiCad attempt, having a go at trying to update some KiCad code and having some issue trying to, was it implement or integrate that code into the main base code or something, was it? I didn't really understand what you're doing. I didn't look at it that deeply. But I saw your tuner try and make some improvements to KiCad. Come on, move. Yeah, top side is definitely a problem. Push those two out. All clear. Surprising. Okay. You gave up? Yeah, I saw you gave up. Which is a bit unusual for you, so it must be pretty bad. Or maybe one day you'll get back to it again, or maybe they'll do some kind of a change which makes it easier to implement it. I mean, you can always hope, can't you? I think it's that one. Yep, it was that one. Oh, Ian, that link you sent me the other day for that thermal camera, I'm suspicious that that's a scam link. They emailed me as well individually, but the URL that's linked in the email for the camera is suspicious. So I'm not going anywhere near that one. Recommend you don't either. I mean, this is a nice board. I do like this board. The analog board, at least on my 2002, the quality of that board was not good. The one in this one looks better. Of course, it's better, you know, significantly newer. But yeah, I was disappointed by the 2002 quality of the board. The analog board it was like a cheap board. It's quite surprising considering the cost of the unit. Board quality just didn't seem right. So this thing, as I was saying before, I think I kind of mentioned it, the memory 1 option on this thing is a Dallas DS1230Y, which is the same chip which is used in many things, such as the HP 3458A. And that can be done with a FRAM upgrade. So that is something I'm going to do with this. I'm going to put a FRAM in it instead of doing another Dallas chip. I mean, I could get a Dallas chip now, it'll probably last 20 years, you know, it wouldn't really matter. Probably outlast the device, to be honest. But I'd rather just chuck a FRAM in it, because I've got a bunch of them now. I purchased a whole stack of things to do this kind of job with. Well, that's exactly why I got them, so that when I do get a situation where it needs a FRAM upgrade, I can just do them. That's the whole point. So. So I think I'll stick a FRAM in this thing. And I think the FRAM is actually still cheaper than the Dallas module anyway, so probably a good idea. Cost-wise, I think it's cheaper. And actually, I was thinking about selling this thing, but now I'm thinking I should probably sell the Fluke 45 instead, and put this where the Fluke 45 is, in my other lab there. Maybe that's what I should do. Not sure. Thinking about that now. I think about it. Yeah, I don't know. Do I sell a Fluke 45? But like I said, I think it's got a continuity option on it, which obviously this doesn't have that. So that might be a benefit, because what I use it for is troubleshooting stuff. So I don't use it very often out there. Actually, I rarely use it to do anything out there. Actually, I've got a bunch of stuff which I should be doing out there, which I haven't got around to doing, as is often the way. Projects which don't get seen. Worked on because I'm so busy being distracted by projects in here. So yeah, not sure yet. Anyway. Alright, that's that done. Now, what am I do about this thing? See if it calls the video, I suppose. Right, so those capacitors replaced. I've got to figure out how to get this one off yet because of the way it's sitting on there. I don't really want to take the whole module off, but I might have to, just to get that capacitor. I mean, maybe I can get under it and cut it and just solder it from the top. Well, it's not great though, is it? Don't really have to take that module off, which is a bit of a shame, but oh well, here we are. Yeah, 45 is nice because yeah, that's one of the reasons I got it, because it had the dual display thing. That's a good point actually. It does have a dual display, so that was one of the reasons I actually chose that. I haven't really featured it much. I mean, I've showed it in video when I first got it, I think. But other than that, I don't think I've really done much with it. What I did to fix it? I'm not sure I even recapped it. I don't think I did that. I think I just got it and it was in really good condition. Don't remember what it was now. Was it 40 when I got it? I can't remember. Honestly, don't remember. Now, trying to get this one out could be interesting. Let's see how we go. Since we've got 6 pins, maybe I can desolder one at a time and get it out. Maybe. See how we go. See if we're lucky. Yeah. I'll try and hold the ball at the same time. No, let's do it. Let's try and desolder and see if we can get it that way. Try and get lucky. I did actually try getting hold of Pro's kit to try and get the latest version of this. The I can't remember what the model number is now. Because this one, I've had it for a while. It's worked really well. It's done me really well. And I emailed them to see about getting a review unit, you know, and no response. So looks like that's not going to be happening. Just showing because I kind of want a new one. I mean, this works fine, but the new one is potentially slightly better. I know that Ian has got one of them. He bought one, and he's used it a little bit. Kind of wonder if it's going to be better than this one or not. I expect it will be based on what I've seen. Doesn't want to do solder. Let's see what we're doing with these legs. Battery option also, yeah. Well, thankfully mine didn't have the battery in it. I don't really need a battery. I mean, if you want a battery multimeter, just get a handheld one. And I've got multimeters here which can do the same job with batteries. Oh, is it stuck? Come on, they're stuck. Right. So one pin which isn't desoldering because it's on a ground plane or power plane. Is that moving now? Yeah, it's moving. It's kind of moving. Yep. Yep. So I think it's got one pin which is still soldered. Just that one there. Which is fine, one I can deal with. As long as the rest of the boot walls, there we go, that's that one out. Which is the other one just stuck. The other one's still slightly stuck. Which one's that? That one? Yeah. That one there. Okay. No, but don't put it back in upside down. Right, got the board out. Here it is. So now I can change that capacitor. The soldering I'm using is that Finersi, what's the model number? DW200 was it? Something like that. That's what I've been using for a while now since I got this one. Before that I had the J... What the hell did I have before that? I had a J... It's a C245 station anyway. This one does 245 and 210. And yeah, what's it? I don't remember. I forgot the numbers. I've forgotten. Yeah, I don't know what J245. Is it? No, that's not right. I've actually forgotten. Anyway, this is the Finersi DW200, I think it is. Something like that. I did a review on it about a year ago now, probably. Been using it since then. Been happy with it. Works alright. It's not perfect. It does have a bit of a bug on there. If you don't have a firmware, if you don't have a temperature set to like a preset, it's got 3 presets there. And if you don't leave it on one of those presets, when you power it back up again, it will jump to one of those presets. So if you say you've got it set to say 270 degrees, you might find it will jump to something else. So it can be weird. It might jump to the highest preset, things like that. So it's not perfect in that way, but you have to watch out for that really when you turn the thing on. Just make sure it's on the right temperature, and you'll be alright. So it's only a little thing. Otherwise, it works alright. I've been happy with it. I did a video showing to add the jumper in a power supply to earth the tip. Although I only used like a, well, I think it was a 2 ohm or 2 ohm resistor I used, something like that. I didn't actually put a shorting link in there, I put a resistor in there, a very low resistance. Yeah, something like that anyway. Now that's a 250 volt cap. At least on the Q3 2002, the power supply is only 60 volts. So I don't know what it is. It's such a big cap. Maybe it is, maybe it isn't. Maybe it's to do with ripple. No idea. Anyway, that's ready to go back in. Which round did it go? That way. Like that. Is it resting on there? Kind of. Make sure it's bedded down properly. Right. So replace the cap on that board. Just refitting the board now. I like to show you a little detail about what I'm doing because you see it all over and over again, lots of my videos. So just going to show you bits and pieces. Just making sure we sit the board back down fully. We don't want it sitting up, we want it to be sitting down where it's supposed to. There we go. Yeah, that's it, it's bedded down. Cool. So put this back in again, and that's this board done. Then we'll work on the analog board. Got to take that out. So we've got to recap the analog board. There's not that many capacitors to do on there actually, it's not that bad to do. And then we've got the fault got to try and find, which is the amps section issue, which I need to have a close look at the analog board on the back of that. See if I can find the parts we need to look for. So I'm going to put up a circuit diagram on that and have a bit of a study of that and see what I've identified as potential problems. Haven't done any physical testing at all in it yet, apart from the troubleshooting. It's that basic troubleshooting thing where you self-test. So that needs sorting out, but that's all right. But yeah, I want to dig into that, and I'm going to look at the back of the board, and probably I might even take some photos of the back of the board. I expect there are photos online. I expect there's photos online from other people. Wouldn't surprise me if there are. Let's just grab this. This isn't really doing it at all. See, it's high voltage here. Got to make sure it's clean, otherwise it could potentially arc. Very important. Make sure there's nothing, no flux residue left behind. I might even use the proper flux stuff for this actually. I882, I'm not familiar with it. I can't really comment on stuff unless I've used it. So, unless I've seen someone else using it and commenting on it or something like that, but I haven't. So I can't really say whether it's any good or not. Right, that's it, all done. Yes, I've made a mistake. Let's put a cable tie around that. Turn this off a minute, get some peace. Okay. Right, that's that board done. That's completed. Put the cable tie on that to hold that down, it's like original. So that can go back in. Obviously, I'll still need to do a frame upgrade. I'll do that after I've got the thing repaired, and then we'll go into that detail as well. But that's those taken out. I mean, I could probably test these and find these all work perfectly fine. It's likely they're all perfectly good. In fact, let's quickly do a rudimentary test. I'm not going to check leakage, we'll just check ESR. Let's have a quick look at this. Short across the legs, make sure they're not powered. So look at this one. ESR 370 milliohms, 983. Short across the legs in case there's any power left in it. Right. 990 microfarad, 370 milliohms. Again, looks fine. I don't expect these to be bad. Not for this era. Yep. Same again, basically. Next one. Which one's this? This is the 47, 35 volt. 47, 1.1 ohms. A little bit high, but probably still okay. That one can't really do with this. And then we've got the higher voltage one, the 250 volt one. 1 microfarad. And that's measuring 64 ohms. Actually, that one's looking a little bit dodgy. 64 ohms seems a little bit high. I'd expect to see maybe like 40 max for that. But yeah, that's alright. Maybe one bad cap, maybe. This one here is probably fine too. These usually are still good. But I don't want any risk of leakage. That's why I'm replacing them, even though they are probably still fine. These are known to leak, so that's why I'm changing them, because they could easily just start leaking next week, next month. You just don't know. Or you could be, this is a good batch because it's a later model, because it's later, it might actually be better. And these might be perfectly fine for another 10 years. Don't know. But if I change them now, I don't have to worry about it ever again. It wouldn't surprise you if they're all Chinese, yeah. I mean, there's nothing wrong with that. I mean, as long as you get different qualities, right? As long as you pick carefully, you'll be fine. You know, just don't get the rubbishy cheapest one, but spend a bit more, get the better one. You do kind of get what you pay for, to a point. So it's worth considering that aspect. What you're willing to pay is what you get. Let's refit this thing. Check everything's out where it's supposed to be. Now what I should probably do is, before we actually do the next board, is retest this one to make sure nothing's gone horribly wrong. Whack some screws back into it. Not going to tighten them yet, just going to get them in place. Because we've got to do the screws on the back here as well for the connectors on the rear. Right. I expect it will work, so I'm going to plug everything in and expect it to work. I'm going to leave that unplugged, so I need to take that. Actually, yeah, I won't route it properly. I'll just put it like this for now, because we need to take all this back off again to get the other side out. Screws are in, but not done up tight. That'll be good enough. Power connector. Can I get that to push? No. Fan. Let's plug the fan back in again, just to make sure it's all good there. Right. Let's reconnect this. That already is on. I might leave it then. Okay. First thing, retest to make sure it still works. just in case something's gone horribly wrong, and we'll do it this way in case you get the magic smoke. Just bang it around because that's always good for it. Right, first power up test after doing nose caps. We'll see if anything's gone horribly wrong. Okay, that looks good. Not going to touch that one because it's 240 volts. That's fine. No heat. So we're probably good there. Let's move on to the next board. Let's put all these back in. Hopefully. I've learned not to do that too tight. Bad experience with the Keithley. The what was that? Well, was that 220? Was it a 220? I did that on. Broke the thing off. I've got one more screw sitting on my desk there. Just trying to see where that one's come from. Oh, that's right, the transistor. Right. So, easy so far. No trouble so far. I wasn't expecting any troubles yet. We'll get to that. Okay. Did that one. Okay, that's that side done. Let's do this board. I will put gloves on in a minute, but I want to get some of the main assembly apart first. Oh, shit. Okay. I just realised something on a 2002. When I put it back together again, you guys never told me I didn't plug all these wires back into the front panel. Oh well, I'm going to swap the casings over anyway, so bonus. Let's do that now before I forget about it again. Let's get that back down. You're supposed to keep me honest, you guys. Completely missed that. How did no one notice? Oh dear. That is terrible. Absolutely terrible. At least I realise now, instead of going, we're going to use it, it's, oh my god, it's dead, it's not working. Because that's what it would have been. Oh dear. At least I bloody remembered. In the end, you guys aren't playing your part. It's supposed to be here to help me out and make sure that I don't make stupid mistakes like that. Now, let's look at these rear panels. See, this 2002. Can you see the colour difference on there? Maybe you can't really see it too much. But there is definitely a colour difference. The 2002 one's a lot more yellowed. So I'm going to be swapping those around. You can maybe see it there. There you go. Alright, so I'm going to swap those around and put a better one on the 2002. And same thing with the casing. Where's the other one? So can you see the casing difference colour? Maybe you can't really see it too much, but the 2002 is definitely a lot more yellowed. So I'm going to swap the casings around as well because they're identical. It's a shame it's got a little bit damage on it. It's a little bit dented and stuff, but oh well. Whilst it's apart again. Ah dear, I know. So these connectors in here are supposed to be plugged in. Ah dear. Right. Let's plug these back in again. These are easy to get apart. It's not like it's really hard or anything. So, you know, that's good. I'll get the thing on there. There we go, there's one. Okay, that's those back in. I don't know. In fact, I need to take those off the other one, so I might leave those out for now. Okay, let's put this cover on this one. Put the nicer cover on, the nicer rear. I mean, it's got a little bit of like, a bit there, there's a bit of dents over here. I mean, it's only minor. It still looks better overall, I think. Just take this ugly foot off this one. Oh, a bit of a sidetrack there. Oh, no, I've lost the foot now. I dropped it on the floor. Never going to see it again. Actually, probably all we needed to do was to take the rubber bang out. Anyway, keep them together. Keep the whole set together. Where'd it go? There it is. Okay. Slightly sidetracked here, didn't we? And the bottom, the nicer one of these. Come on, in you go. Yes, I'm putting on the right way up. Screw that up, be helpful. I don't know. You guys are supposed to point these things out to me. Really let me down. Okay, that's that one done. I bet it works properly now. Okay. Back to this. Alright, so we've got white and blue goes there to the amps jack. Got black and white goes to the black one. We got something else goes to that one. We've got enough to get this out now. Maybe. Come on. This ferrite thing's a pain, it really is. What's that one? It's a red one. Pull this off. What? Come on, a little bit more. Doesn't want to pop out. There you go. Yellow to that one. Hope we're moving these colours and stuff. It feels weird. No, that's all right. Same for the front. Hey Steps, how's it going? Destroy CMC, yes indeed. Trying to get the damn things out. Wish they just had like a little bit longer wire on these. Literally the wires were 2 or 3 millimeters longer. Then it'd be so much easier to get these things out. It's incredible. Anyway, haven't broken anything. I'm both out there breaking them, so that can't be too bad, can it? So this is a 2001 Idiot. So it's not so bad. I had a 2002 part before because I was doing some more changes to the software before on that one, or the firmware on the display driver thing. So, and yes, I'll be chucking some gloves on in a minute once I get to where it's critical. Don't forget to plug the wires in the front panel. That's useful. Scared to ask why. Well, you've seen the video I did on the 2002 TFT upgrade. I saw you comment on that, so I know you've seen it. I just made a small change to it to add a space between like millivolts and the actual numbers, like so the string of 8 digits. If you're doing 7 digits, it's fine, doesn't matter. There's already a space. But when you're doing 8 digits, well, and half digits, there's no space there. So I've added a bit of a hack in the code to add a space into that, so it spaces out the millivolts and from 8.5 digits to make it look a little bit nicer. And also tried just changing some of the display timing, just to try and slow down the writing to the display, try and reduce the chance of glitching on it. And it didn't seem to help much, really. I think it needs more investigation. But I mean, it works. It's very minor glitching. It's almost imperceivable. And it's only really because you're looking for it. If you're just using a unit, you probably wouldn't notice it. So I'm dropping the bloody nuts everywhere. Who are they? I dropped both the nuts and it disappeared. There's one. Where's the other one? There it is. So this one here needs recapping. Obviously, you know, I've seen you fixing these things. You know what I'm dealing with here. Only this one currently looks okay. I've already done the digital board. I've just got to do the analog board and go through that. But also I've got to get the board out first to recap this one. This one has an issue with current. It's failing on current. Current mode is failing. It's I can't clamp it down. It's being a bit of a pain. The come on, get in. Yeah, the current's failing self-test and it's reading very incorrectly. So if I put in, say, 20 milliamps, it's reading sort of 30 milliamps. If I put in 1 amp, it's reading 1.9 amps or something. Like it's very out of whack. But then it's probably because it failed calibrations. That could be the calibration constants are completely out of whack. But it is reading current, but it's just very wrong. So that's where that is at the moment. But I haven't got this board out yet. So once I get the board out, we can look for that. And I just want to see if there's any parts on the back of the board, which will help me to diagnose that. I was trying to find the like CR 305, I think it was, and 309. I think that's what the parts were from the circuit diagram. Thankfully, it was a circuit diagram. I also saw you'd done some reverse engineering on this as well many years ago. A dozen years ago, you did some reverse engineering on one of these things. So I was looking at that before too, trying to see if there was any clues in there. But come on, trying to get this IEC connector out. It's a very good clip on this one. So this one seems to be dated from 2008. So it's not too old. It's not too bad. Right, let's get this transformer out here. Now I'll put some gloves on, take the board out, hopefully. That's the plan anyway. Go on, unhook. Yeah. Kind of hooks in down there, look. But it's not wanting to unhook. I did a 2002, it came out a lot easier than this. There we go. Right. This gets it out of the way, gives you more room to move, doesn't it? Okay, got to disconnect the push rod here for the front, front rear switch. Actually, you don't have to take the front off anyway to get that out of the way. I think I might have needed to. Oh no, maybe I can do it. Maybe I can do it without doing that. I'll read the chat again in a second. There we go. There's it. Of course, it got hung up in the wires. And now it's on the floor. Oh no! Cal's gone to sleep. Wake up. Jeez. Should read the chat more often. Jeez. At least you can still hear me. You're still here. I'm gone to sleep myself. Anyway, I didn't miss much. Just me struggling to get the transformer out, really. So that's that. We'll get that push rod there out for the power switch, which is basically off anyway. Right, get those nuts off that. To have a driver fit those before. Ouch! My draw's left open. Where is that one? Where did I do that? Is it? No. That's not looking like that. Yeah. Is that one? Is that loose already? It is loose already. Okay, convenient. Well, my phone is in here. Yeah, my phone is actually in this room. So if something were to go wrong, if Rob was here, he could text me. Rob's got my number. Alright, so's off. That's good. That's that done. I think all I've got to do now is put some gloves on and slide the thing out. Ian's been working on the new 180, in case anyone doesn't know. The replacement U180 hybrid thing, which is in the HP 345A, which is failing, and he's having a go at it as well, having his take on it and just trying some things. So the more people that have a go at it and try different things and different experiences, and they like, it's got to be good, isn't it? I mean, I've done it. I've done it on my unit and I couldn't get mine working. I didn't try very hard, it just wasn't working. I haven't really dug into it. I think there's a secondary issue on that A3 board on mine. So I've actually done video on about it, but I haven't published it yet because I haven't really finished it basically. So we're not there yet. Oh, so I'm going to take these off. So yeah, that's in progress for me as well. So it's not quite finished there, but it's getting there. And so I'm going to come back to that myself as well. But right now, I've been distracted by other projects, and so I haven't got any further with it. I've been distracted by getting a second unit and getting that one working, and my 2002, which I've worked on. Obviously, you've seen those videos. That's right, I've got to get the amps jack out. That's right. I forgot about that from last time. Let's get that out. Oh my god, custom A3. Well, I've seen, was it MIDI done it? Was it MIDI? Someone's done it. I've seen someone has done that. They've made their own board. That'd be nice. Then it's a case of programming the thing and whatever, and there's so many variables in that though, isn't there? It's like, you know, what could possibly go wrong with it? If I can't even get the new 180 to work by itself yet, I've got too much to consider. Anyway. borders out. Let's recap this beast. So the only capacitor I'm suspicious about is this one here. It just looks slightly more rounded on the top compared to the others. I don't know, maybe that one too. I don't think it is actually bulging. I think they're probably still fine. I haven't seen any signs of leakage or anything, so anyway, yeah, just to know really, but yeah. Let's get this thing off here. Yeah, you do seem to move a bit, don't you? Do seem to change your locations fairly often. Must be a bit hard not to be settled down somewhere. Okay. No thermal pad. That's interesting. I suppose it's only needed in the other one. Because the other one's got a thermal pad. Like the 2002's got a thermal pad over here. This one doesn't have it. That's good because those things go a bit yucky. So things I need to try and find are those input circuitry protection things. Let's have a quick look around here. Nice sitting there for wicked, yeah. Yeah, 10 yeah. Right, let's have a closer look at this. Now I just want to try and see if those diodes are on this side. I'm only seeing resistors so far. Yeah, so right now I'm a bit puzzled about where those bloody parts are. Maybe you know, Ilya. The CR305, CR309, those input protection diodes. I know you reverse engineered it, so I know you would have looked at them at some point, but that was a while ago. I haven't found them yet, so I'd have thought they'd be like in this region somewhere, but I'm yet to find them. CR305 is a bridge, yeah, I know that. But I haven't seen a bridge with the marking on it. Oh, this CR309. There we go. There's one of them. There's 309 right there. Don't know how I didn't see that before. Seems pretty big. I was looking for something smaller. Oh, there's 305, that big bridge there. Okay, there we go. It's really bloody obvious now I'm looking properly. There we go, those two there. Those are the two parts which I need to check for input protection. Because those could be there. They're coming up as potential errors. So that's where I'm sort of thinking that they need to be done. I should record some more video on this, shouldn't I? Right, so I've got the board out of this thing. It's always a bit of a challenge getting the board out. They can be a bit fussy, lots of connections to take off and that sort of stuff. So what I was looking at, I was trying to find these two diodes. One of them I knew was a bridge. And for some reason I couldn't find them. I was expecting to see smaller parts or surface mount parts. It turns out they're here. C309's there, C305 or CR305 is there, right? CR309, CR305. They're massive parts. I don't know how I didn't see them before. So those are input protection circuitry, are part of that stuff. So I need to check them. But yeah, I need to verify basically the input side is working okay, because it is giving errors. Was it 309.1, 309.2, 309.4 or something? Where's my list? There it is. There you go. Here's all the parts. These are the error codes it's giving. These are parts which are mentioned in the service manual, and these are things I'm suspicious of being potential causes. But if these input protection are shorted, that might be causing issues with all these other ones. So that's why I'm kind of thinking these are nice simple parts to check first before we go diving into things like switches, which is what these things are. R591 is one of the shunts. Unlikely to fail, but it's a commonality. So it's possible, but very unlikely. So let's quickly check these diodes and see what we're getting on them. So it's a nice, easy and quick check to do. Then I'll start doing recapping. I think I'm kind of tossing one to the other, but okay. There's one diode there. Nothing that way. That one looks fine. That's 309. There's the bridge, so we should get some multiple junctions on this one. That looks good. That looks good. Reverse them. Good. There's me touching the probes together. Yep, it's fine. Those bridges look alright. Bridge looks alright. The other diode looks alright, so I think I can rule those diodes out. So, I wasn't expecting it to be bad, but it is a possibility. It's just something reported, but it could have been an earlier failure making it think those are bad. So, I've eliminated one thing. So, we can check it off and say, they're good. Let's get a pin. Those check. Okay, I'll cross those off. That's good. Right. Let's do the recapping, then we'll come back to do the troubleshooting to try and narrow down what's going on there, because I might have to go probing on switches and stuff like that with it live and just see what switches are doing and things like that, because it does use some DG4. Is it 444s or 201s? I'm not quite sure which ones it uses. Let's actually pop this off and have a look. What have we got down here? DG211s. Okay. 201s BDYs. So U320 is one of them. 323 is another one up there. One is that capacitor which is bent over. So that one there is another one which is suspect. So a couple of switches. So a quick visual inspection around there. Interestingly, the board around this part here, U324, looks a little bit yellowed. Looks a little bit discoloured around there. Let's show you. So there's 324 there, and just to the left of that, you've got that little dot. And to me, it's looking a little bit yellow around there. It's a bit, maybe it doesn't show up too well in camera. This looks very slightly discoloured at that end. Could be nothing. Don't know, it doesn't look like much, but camera doesn't really show anything up. Maybe it's just shadows, it's also possible. But yeah, I don't know, maybe you can see something there. That little square. Anyway, do a visual spec first. Visual check first. Right. Yeah, there's stored a board over here. That's for the isolation barrier, digital isolation. I think there's other chips in there. It's like 4 other chips, and they've got this as a adapter, because the original ones, I guess they're not available anymore or something. So this is in some of the later ones. So that's not always there. Depends on whether those other parts are available. Those opto couplers, that's what I'm looking for. Auto isolators. That's what's normally across there. As Ilya just said. DG411s as well. You reckon there's something there? Oh yeah, there's a 411 down there. Yeah. I've got both of those parts. I've got them in stock. I did actually buy a bunch of them. So if I do need to change these switches, that's not a problem. And I think Now I've actually done 2002 and I got a little bit of familiarity with these things. I'm feeling a bit more comfortable about trying to track down what's going on, especially as I've got a circuit diagram for this one. That certainly helps. So, yeah, okay. And as it's just basically resistors on the back there, there's not much to think about on the back. I'm just going to have another look just to check for any damaged resistors, just in case there's any burns or anything on them. Just in that input circuitry area. I'm not going to check the whole board, obviously, just around there. You've got CR518, 519, I'm not quite sure what they're doing. Then they're near there. Might just check those whilst I'm thinking about it, just in case, you never know. Sometimes randomly checking parts can reveal something. As it turned out, to how I fixed the 2002. Oh, interesting. That's a short. So is that one. Both directions? Yes. CR518 and 519 both showing as shorts. That's interesting. Might have to look at the diagram and see what's going on there. One end connects together. Not quite sure what they go to. It's interesting showing as shorts. I have to look at the circuit diagram for those. That may or may not be relevant. 2012, that's right, yeah, newer versions, eh? So, right, I'm kind of getting sidetracked again. I want to recap this, get the recapping done, and then I can focus on the troubleshooting side of it and get through that. Maybe someone wants to look up CR519 and 518 and see what they're doing. See if a short circuit on those can potentially make sense. 2.2 ohm resistor across them. Okay, well there you go then. Thanks, David. That makes sense then. Right, let's wake the soldering irons up and start recapping this damn thing. Let's see what caps I've got, because I don't think I've got all of them. I'll certainly have that, whatever that is, it's small. 2235s, I need some of them. Everything's stacked in front of my drawers, of course. 50s. These must be some of the ones I wanted then. These are big boys. I've only got one of them, which is a 50. Yeah. Height-wise is okay. That'll fit physically. That's a bit tight. This is probably some of the ones I needed to order. Yes. Right. Those ones could be problematic. We've also got 47 at 63. At 400, I think that's a bit excessive. Oh, this could be a problem if I don't have the parts I need, because I don't have them. It's a 47 at 100. Is it sure it's a 47, not a 470? It's a bit massive size difference. 470, that would make much more sense. Definitely want to put the right one in. Put those back. That should have been obvious when I looked at it. 470. In fact, if I put it in the right place, it would be even better. Right. Yeah, zoom out a bit so you can see a bit more. 470 and 63. Check. How many of those do I need? 2. 2 of those. Right. don't have two the same. Where's the 50s? Oh dear. 50s. This is another one I needed to order then. Right, this is going to be a problem. I don't have all the caps I need for this. Do you reckon I'll get away with 50? Can I use 50 in here? I don't like to reduce the voltages. So that's C114 and C115. I wonder what voltage those rails are. David, seems you're probably in the circuit diagrams already, can you have a look? So you can find out what voltage I have to use in that section. Because I've got 50s. I always like to try and use the same style cap across the whole unit, you know, so it all matches. Oh, that's fussy like that. Yeah, I've got hoops of 50s. Because if the supply voltage is below 50 volts, you know, significantly below, like 40 volts or something like that, then I'd be happy putting 50 in.
Coffee?
Yeah, okay. So that's those ones we've got a problem with. What's the next ones we've got a problem with? So that's another 2200 at 16 volt. Again, I don't have anything for that. Those ones are ordered. Yeah, this is annoying. Okay, what's the other one? 1000 microfarad 35 volt. Might be able to do a full recap on this thing. I might have to pull this thing apart again a second time later on. 1000 microfarad 35 volt. One there. And 25. Oh, come on. There's a 35, which I've obviously put in something and taken it back out again. I'll assume it's good. Boost rate voltage up to 38 volts. So 50 might be right then. Okay, thanks for that. Alright, I'm going to go with a 50 then, and hopefully it doesn't go horribly wrong. Let's go with those ones. These are 105s, aren't they? Yeah, 105 degrees. We go with those, they're similar size. I really wish I'd done a digital now for these capacitors instead of delaying them. Because I was replenishing stock because I realised I was a bit low on these things, and so I was going to buy more. So that was a bit annoying. Right, what's that last cap down there? That's a 1050. Okay, let's put the 1000s back. $1,025 or something like that. 35. Geez, is that everyone I've got? That big bone. Will that fit? Physically, height wise, it will fit. Yeah, I'm just going to have to use that one. It's not a great fit. Yeah. Definitely need to restock on these bloody values. This is really annoying. This is why I keep so many caps here, because, you know, when you want to do a job, you need to have them on hand. Not having them on hand is really frustrating. I should have spent the money and got them all in one go. Alright, that's those big caps there, mostly. There's a couple I don't have. I have to make sure I mark those and I don't change those ones. Those ones there, wasn't it? Well, that small one there. Is there anything else? No. What's that small one? . 100 at 10. Okay. definitely have something for that if I can get the drawer out. So 35, so that's something a bit smaller in the voltage. I'll have to get it closer. Or 25. I'll find a 16 would be better. Is it a smaller 25? Okay. What's the rating on that one? 105. Yeah, okay, I'll go with that one. That'll do. Right. Take the glass off and see what I'm doing over there. Can I get the drawer again? Right. These glasses I got from AliExpress, which I've got for doing close-up work, are actually really useful. Because my eyesight's, starting to go now. It's getting quite bad. Normally, like if I'm at arm's length from that onwards, it's fine. It's just up close, and so these glasses are working perfectly for this. So I don't have to spend hundreds of dollars on glasses. These are like a pair of, I don't know, like $20 glasses or something. They work perfectly for this. Right, let's start replacing these caps. Let's start with a small one. Get that one out of the way. Hopefully this board's a bit more forgiving and a bit better quality than the one on the 2002, which I was really unimpressed by. The quality of that board was not good. This is definitely a different material, so I'm hoping this will be better. Hope they will go that easily. I doubt they will. Okay. These ones here. Yeah, those are a problem, aren't they, because of the sizing. I'll leave those ones for now. Let's come to these ones. Once I find the sights, there we go. Yes, I'm grateful there's no leakage present, that I can see at least. Nothing I've seen. Doesn't mean there isn't. Nothing I've seen. I'll walk them out and then clean the holes out. Often it's just the easiest way of doing it. No leakage on the bottom. Board looks good. Double check that one. Yeah, that's fine. So this one here I was going to put in, what was it? That's a 470 at 63, which I was going to put a 50 in, wasn't I? Which was one of these ones. So at least there's no signs of leakage yet, that's good. That was the same one, wasn't it? Yep, do that one as well. I don't know, anyway. So I think I got lucky with this one as far as leakage and stuff. I was expecting leakage because of, self-test failures. But thankfully, nothing. It's out. Not quite. leakage, nothing there. Looking good. Hopefully they all look good. Next ones were 1035, which is what those ones are for. It's two side by side. Okay. Should probably record some more video. I should also probably turn my film extractor on. That's why I own one after all. If I remember where I put the remote. It's here somewhere. Okay, where did I put the remote? There it is. Enemy spotted, yeah. Caps on, yeah, replace on site exactly as I'm doing it. Even though the caps I've already pulled out on the digital board all look perfect apart from one of them. I was a bit suspicious about the 250 volt cap that's on the driver for the display. That one had a ESR of 60 ohms. All the others looked perfectly fine, and physically they look good. There's no signs of bulging, nothing like that. So, but this era on these Keysights are, as you know, well known for having this issue with dodgy capacitors, and it's as best as to take the damn things out and not worry about it anymore. They're probably, you know, measuring perfectly fine, still perfectly within spec. You know, electrically nothing wrong with them. But, as you know, physical failure. Let's record the video. So I'm going along, I'm most of the way through this cap replacement already. I'm not recording much video on this because I don't really need to repeat all this sort of stuff all the time. I don't have all the caps I need. Frustrating, I don't have enough stock. You wouldn't believe it, would you? And so I can't replace every single one of these. I think I've got a couple I don't have, which is a bit annoying, but you can't do much about that. So I'm just working my way through these now and replacing what I have with what I have. No signs of leakage. It's always good. I'm checking for that every time I take a cap out. Make sure there's no leakage present. This one here is one I've used before, but it should be fine. Is that the right one? That's one over there. There's one over there. I've lost one. I've lost a cap. I need to get another cap. I think I might grab the wrong one. 1035. Right, one of these. I'm putting it right around. Did I put that one in right around? I better check now. I'm not sure I did. No, I didn't. So I double checked. That went bad. That's right around. Okay. So that's those four, that one. These two I don't have. I've got a 1063 here. Now I do actually have this one here. 1050, which is what that original one is. Don't remember, I might just put that to one side for now. I'm going to put this one in. It's not exactly right, it's a bit big, but it'll fit. Again, I don't have all the right caps. There's a few caps I don't have. I don't have that one, I don't have these two. I don't really have that one. What I've got will work, but yeah. Anyway, I'm working through this, so I'll let you know when I'm done. And we'll go back to doing troubleshooting and find out what's going on with this error codes. On 50 degrees C, really? Okay, reps, yeah, it's brilliant. Don't be without the right caps. Yeah, I know. Obviously, I've been neglectful in my capacitor. Can't say in my capacitor purchasing. I need to buy some more craps. It certainly seems that way. Now I'll take this one out and see if this one will fit. I'm not even sure that's the one I just. Is that the one I got out of the drawers, or is that one I was taken out? It looks like one out of the drawers. I can't see the soldering legs, so I think that's the one I did get out of here. So that one would actually fit. I'm not sure about it now. Anyway, let's get this one out. I'll see if I can get the bigger one to fit in there. We've got to clean that iron up, it keeps on making bad contacts. Right, let's put this one in and will it physically fit? Physically fits, then it's going in. I think I was saying problem I did in 2002. It was a bit tight. I'm not completely sure about the height, because that's the limitation of height I've got is there. There we go, it's below the height. That'll fit. I have to set it above the other components, so it's not great in that way. So yeah, it's going to sit like that. It ain't a great fit, but it'll work. And again, there's no signs of leakage on that one as well. Should probably come on in there. Right. That is. My desk is awfully cramped and messy. I don't like that. Got to clean that thing. Stop complaining. Turn off. It's the collar on the mount with the cradle, you know, with the iron touches on the outside. It's a little bit dirty there, and it's not making good contact. Just gonna need to give it a clean. Do it occasionally. Right. Let's see if there's anything else I can possibly do. So we got those three, which aren't done. And they're all 2200s. I mean, can I do one of these or not? I mean, if I can get these other ones in there, I'll be alright. Maybe I'll do two of them. Marco Rips is only going for more craps, by the way. Oh, that's brilliant. Oh dear. Should send me a big box. No. Ian's already done that, and yes, I've had quite a few caps used and put into my other storage bins and stuff, because a lot of those are like film caps, stuff like that, and they get used from time to time. But yeah, I just need to restock myself. I've got them on my shopping cart. They're on my DigiKey shopping cart. They're there, but I had to prioritise what I purchased because I couldn't afford to buy the whole lot. And unfortunately, I didn't buy the caps. I should have bought some caps. Anyway. Yeah, the power supply is an interesting design, isn't it? So if I can get these in there, I can replace these two. I think they will maybe just go. It's going to be tight. Then I've got this 50 volt one over here, which height wise will go. That is outside of that cage, that plastic cover. That's outside of that cover, so that might actually fit in there. It might go. I might have just enough. Maybe. I don't want to revisit this thing. I don't want to be coming back in here and do it again. You know, it's a bit sad though, isn't it? I have to get more. Yeah, I remember looking through my capacitor storage last time. I've got like a box of overflow caps where things don't fit in my drawers. I remember looking through those last time. I didn't have anything. I was looking through those for ages. I'm sure I did have some, but I didn't. So it's let's change these other ones. Where are they? Keep losing them. There. Let's change those two and hope for the best. Which round are they? Opposite each other. Okay. Yep. Right. Just make sure the marking's right. I'd rather use the right caps and get exactly the right size stuff, but yeah, if I ain't got them, that's a bit of a problem. Really got to clean that thing. And once we've done this bit, we get to the interesting part where I try and find out what's going on with the amp circuitry. No signs of leakage, excellent. Will they both fit? Ish. I'm not happy with this sitting in there. Raised off the board. Not happy about that. I'll get it down the side of that. Yeah, I can just get it down that way. That one's alright. No, I'm not happy with that. Also not sure about the fact that it's touching that resistor leg. So like just there. I don't like the way it's resting against that. I might need to try and move that over so it's not actually touching it. I'm not quite sure what that's doing. It may matter. If I can move it. Isolation might matter. There you go. Bend it over a little bit. What's not touching? I mean, even if it's, I don't know what that leg is doing there. It's R636. Not sure where that's going. It may matter that it's not touching something, you know. Could be important. Just try and move it over a little bit more. So A clearance. Yeah, okay. So that will fit. I can get that one in. This one here has to stand up because of this board sitting here. Can't quite get that one in there. Won't sit down flush. I mean, it'll go in. It's got to stand up like that, which I'm not happy about. Yeah, get on shot. As I put this one in instead. But then I can't change that one because that won't fit in there. Think I'm gonna have to live with it. Yeah, not happy. OCD much? Yes. What are you trying to say? Yes, I want it to be perfect. The thing is, it's attention to detail which can make the difference between something working and something going horribly wrong. I'm just going to put some of this on here. It's like an insulation, maybe. Oh, no, that one. The other one. Got the right one. Put a little bit of that on there, just to provide a layer of insulation, just to create an extra barrier. In case it matters. A little bit of that. Could be a really bad idea, but we'll find out. I'd rather not have a direct contact to that leg. So I'll put an extra resistance layer of insulation between the two. That's all I'm trying to do. Right. Okay, let's put this in. And actually, I'll let it front dryer. I can't put it onto that one then. No, to wait that dry for about there. Let's read the comments while I'm waiting. Right, so I decided I'm going to try and squeeze these capacitors in there. They barely go. It's going to kind of sit high, that one there. I can't just sit that one right down. This one will just go, but it's really close to that resistor leg. So I've moved it out of the way very slightly. I put a little bit of insulating, like liquid electrical tape on there as well, just to try and create a bit of a barrier, just in case there's like a potential leakage path there, you know, or it's otherwise only relying on basically the heat shrink on the outside of the cap to get it away from the can, which may not be a good thing. So extra layer just to be sure. Probably doesn't even need it, but I'm just being cautious. And yeah, get in there. So then I can do this cap as well, because I've got one cap left which will probably just fit and then at least I've recapped it. But I'm not happy with the caps I've used in this position, those positions. So I wish I'd ordered the right ones, or ordered some at all to be correct. But anyway, getting there. Read the chat. Not a pretty design, nah. What if it wasn't? Kept on tape, yeah, that's true. That's a good point. I could do that. I shall do that too. I do have some crapped on tape. It is crapped on tape because it's Chinese one, so I'm not quite sure what it's made out of. And I've just dropped it down the side of my drawers. Now we'll try and find it. Where'd it go? Oh, there goes another one. There it is. Okay, crapped on tape. Now, the problem is I've got gloves on, so I can't actually get the end of the tape, can I? I'm sure that's the end. Yeah, that is definitely the end. Like I said, who knows what this actually is. It may or may not be capped on. I don't think it is. Anyway, we got some. Goes on the negative side. Crapped on tape around there. That's a good suggestion. I don't know why I didn't think of that myself. Yeah, it's a shame this almost goes. Just so damn close. I mean, no, I definitely can't shove it down next to it. Definitely not. So I'm going to do the same thing on this one as well, just to insulate from that board a little bit. I don't think it's going to matter that much, but while I've still got the tape here, I might as well use it. And that's going on that side, yeah, a little bit there. There we go. Cracked on tape on the side of that one as well. Just seems it's going to be sitting above that ball. Right, let's put these in. Normally I worry about getting them down on the board. One of these I definitely don't want to do that because I don't want to sit on directly on top of that other one. I actually want to have it slightly up. Yeah, I'm sitting fine, I think. Yeah, that's alright. Yeah, well, I'll be getting on to the actual original fault shortly, but my philosophy has always been recap it first. If it needs doing, just do it first, because sometimes recapping it fixes the problem. There's been plenty of times when recapping has fixed the problem. It's a really common failure point. So I'm not worried about that part. And so I've always preferred to recap first and then troubleshoot, because you could spend hours and hours troubleshooting some weird, obscure fault. And you can track it down. You can certainly narrow it down and figure out, oh, you've got some problem in this particular part of the circuitry, you know, and you can get right down there and figure it out. You can absolutely do that. But you could have spent hours and hours doing that, when you could have spent half an hour, maybe an hour, recapping the thing, and saved all that troubleshooting time. You know, I mean, sure, it's education or whatever, but sometimes it's best to not worry about spending all that time doing something like that, when it could be done so much more simply, just by basically shotgunning it with caps. I mean, I know it's not exactly a great process to shotgun a thing with caps. It's not very professional, I suppose, but my experience has been replace the caps. Time and time again, replace the caps. That's my experience. So, yeah, that's where I'm at to. So I'm going to get the worst flux off of this, and I'll give it a clean the other stuff. Use the proper stuff. Looks right. What was the number of that resistor? That was R363. Yeah, 363. Bit of sealant, yeah. Alright, that's good. So the question is, do I put it back together and then test, or do I try and do it on a bench? I'm inclined to put it back together and then test, and I think it's going to be top side of the board anyway. I don't think it's going to be bottom side. There's only resistors and capacitors on the bottom side. I mean, it could be a bad cap. Leave this running for a bit longer just to get rid of some of these fumes. That's irritating. And my wife bought me a coffee. I should really drink that. And I forgot, there's one more capacitor to replace. I don't know what that clean up. There's one more cap. You guys didn't tell me again. Jeez. That one. Still got to do that one yet. Almost missed it. 4 ohms loan circuit. Okay. So leakage might be a thing you have to consider. Yeah. Come on, solder. Get off it's cold by now. Oh, it's getting there. No leakage, that's good. Alright. Will this fit? I hope so. I think this is going to be a no. It's also too high if it's sitting up. That doesn't work. $2,250 will not fit. That's annoying. Let's see if I've got something here for a fit. There's a 16 volt, wasn't it? So I'll put in a 3325 volt, if that'll fit. It may also not fit. Height wise, I think it's okay, just but still massive. Not happy with that. This is why I try to buy some more caps. No, I've got the coffee now. Look, there's the coffee. Coffee's here. I'm trying to drink it. No, there's no cats today. No, the cats are locked out of this room. The door is currently shut, so they're leaving me alone. And my wife is out in the other room, so they have a person to be near, so they're happy. Right, I'm going to drink this, then we'll carry on. I'm trying to figure out what to do about this. So what does C... No, let's have a look. So what's your voltage regulator circuitry? C106. C106. What's that thing powering? I mean, physically, height-wise, I think that'll go. It's a bit of a bodge. I really don't liking it, but you know, it will go. It's close. I think it will just fit. Yeah, okay, how's it going? I'm not happy with it. You know, going from that to that is just a bit ridiculous. even that's not going to work, I don't think. Using an axial. Nah, probably going to be no benefit. If anything, it might be more risky. That's really irritating. I don't want to leave it with just one cap not changed. Input side of the 5-volt regulator. Okay. The issue, triple X dread, the capacitors that are used in these units are known for failing, not electrically, physically. So what happens is they will physically leak the electrolyte out. So it's always a good idea when you get one of these things, which is a Keysight 2001, in case you haven't followed along, is to replace every single capacitor in the unit, because the last thing you want is one of those capacitors leaking and destroying the circuit board, because that's what happens. So even though electrically all these caps I've taken out are probably perfectly fine, absolutely nothing wrong with them, physically they could start leaking any day now. So if they leak, it will destroy the board. So it's common practice to people which prefer to do this sort of thing. I'm experienced doing this sort of thing. In this particular unit, or even older equipment like this thing is still 18 years old, from what I can tell. It's a good idea to replace the caps, because even if electrically they're good, physically they may not be, and they can fail. And so this is a preventative measure just to make sure that there's no leakage happening inside here and it's not going to cause any problems, you know, because when these things leak, it does destroy the circuit board. It's very fine componentry here. It's a multi-layer board. It gets inside the layers of the board and eats through the traces inside the board, that sort of stuff. So it takes a little bit of care. So I mean, these caps are on my order list from DigiKey. That's the annoying thing. I just wish I'd bloody ordered them. I mean, that will fit. I just don't like the way it fits. I mean, it looks like that. I mean, it's awful. I mean, sure I can secure it. I can, you know, tack it in there and make sure it doesn't move around and make it physically stable. And maybe get it away from the heatsink slightly. And it, height-wise, it will fit. I just don't like it. It's not very professional. But I'm going to put it in like this, even though I don't like it. We'll just never speak of it, okay? We'll pretend we never saw this happen. Everyone will sort of stick their fingers in their ears and pretend it's never happened. Okay? That's by far the best outcome. Because if I'm not happy with it, you can absolutely guarantee there's going to be dozens and dozens of commenters when I record video about this thing, or when I publish a video about this thing, doing this repair. There's going to be dozens of people commenting, oh, you should have put the right cap in, you should have taken it apart again. I mean, I may well take it apart again. It's entirely possible that's exactly what's going to happen, as I'll revisit this and take that cap back out. But right now, that's not what's happening. Just want to get it away so it's not resting on that heatsink. Right. I'm going to rest it on the capacitors behind it and not on the heatsink. Like that, so I can brace it. I can brace it against those caps, so it's supported. It will do. If I revisit it, I'll change it, obviously. But yeah, I'm not happy with it. I would certainly prefer a different capacitor for that position. But anyway, well, there's 3 caps here I'm not happy with. 2 really I'm not happy with. Yeah, I mean, in fact, there's so many which I'm not happy with. I might come back and revisit this later on. Anyway, let's get this thing back in and we'll carry on with troubleshooting the damn thing. Actually, I should record a video about that. So, boarder's now done. I put the caps in, which I can. I'm not happy with a couple of them. I may come back later on and revisit that once we've got some more stock of those capacitors, because I'm not happy with the fitment. But they'll physically work. Now, they'll do the job for now. And I can carry on with refitting this back into the chassis now, and then we can go back to the troubleshooting stage and trying to figure out what's actually wrong with the thing. And where's my remote gone? Here it is. Turn this off. Get some peace again. Yes, bloody irritating. So I've upgraded that to a 3300 in order to get a slightly smaller one. Yeah. So it's an upgrade and a downgrade at the same time. There's nothing wrong with that, is there? Actually, do I? Actually, still really happy? No, I'm definitely not. Dumpster drive. Yeah, no, yeah. Oh no. Yeah, well, I mean, I do buy high quality caps when I'm doing this test gear stuff. I do have some cheaper ones too, but I generally use the cheaper ones for like consumer equipment, which isn't supposed to last 20 years. For test gear, I always put in the high quality stuff, so that's what I'm doing. If I'm doing test gear, I'm putting in decent parts, as much as possible. Anyway, sometimes I don't get that, but. Let's put this back in. Wiggle it back in again at the right angles and it came out a lot easier. Came out a lot worse. Yeah, going in back in was easier than coming out, certainly. Jeez, that's interesting. All right. No, it's not right down. It's not right yet. Can't do it. It's not sitting quite in the right place. I've got to feed this through. It's not sitting in the right place. Come on, we'll get a flex through here. And you can't see what I'm doing. Zoom out slightly more. There you go. So the flex doesn't fit through, it's sitting in the wrong place. It's holding the board up. Yeah, it's still not in my place. Through there now. Yeah, now it's through. Right. Now I've got to try and get it slid in the right place. There we go. That's better. Do you know what I've done? I'm an idiot. You see this piece here? I should probably put that back in, eh? We'll put this back in. I think that'd be a much better idea. So if I can do it that distance, I think I can get back out, but no. Where's the post? There's the post. Right. This flex is really getting in the way of everything. Right, let's do that. Okay. Now we'll put it back in again. Maybe this time, eh? Okay. I think we're good. I think we're good. I'm going to hook these wires up now. Before I do anything else, in case I forget them again. Now it's probably easier to put these back on again once you put the ferrite back on, but I'm not going to do that yet. I'll wait until I put the other bits together. Got the one there for the current. I'll feed that through there too. Hopefully I don't take the ball back out again. Well, at least until I revisit those caps, but that'll be weeks away yet before I buy those. Well, I'll probably buy them in a couple of weeks' time. So it's probably going to be a month before I revisit this thing. Sensor wires are sense over there. Okay. I'll probably put this back together again and then find I put one of the capacitors in backwards and it's going to go bang. That happened once when I was doing a CB radio. I think I was recording video at the time. Yeah, I was recording video at the time. And this is a while ago now. And I was distracted, as happens when you're trying to record videos and doing live streams and stuff. It does split your focus, and so you make mistakes. And yeah, so I did that and had a capacitor in backwards, and it's quite a big cap. On a 12 volt line, I think it was. It's quite a big cap and everything, so it was impressive the amount of smoke that came out of it. Okay. Should I put that on the riser card? I will. I won't put that back in yet. Let's put the transformer back in. The worst bit about these is that they're a little bit fiddly. There you go. Anyway, there, and goes there, not off by one pin. This gets put back on here. This earth goes there. It's quicker to get it together than it is to get it apart. This is when you don't have gloves on. Yeah, I'm not doing CB radio after this. No, I used to do a lot of CB work years ago. You may know my main website for CB stuff. It's quite big. radiomods.co.nz. You may have heard of it. That's me. So, done quite a bit of radio stuff over the years. I don't really do it much anymore. I've kind of moved away from it. Mainly because I just don't have time. I'd rather be working on things like this than CB radios. I do have some CBs sitting there waiting for me to get around to doing them. I just haven't got around to doing them. This is the way. Now, this was in upside down for my liking, so I'm going to put it in the other way up. Hopefully I'll get the wires around the right side. Did I get the module? No. That module there I'm going to put in afterwards. I've got a riser card which I'm going to put onto it so I can more easily test when it comes to the diagnostic stage. I showed it when I did the 2002 repair. The riser card that I built for doing that. It just makes the job a lot easier. Because otherwise you're trying to probe underneath the card and that's just a bit hard to do. Should really get a spanner out for this, but I'm being lazy. Come on, get down. Okay. That's done up. Yeah, those are plugged in. That's plugged in. Front rear switch is going to be on front. Okay. I think. Therefore, I am. Is that right? That's done. Those are definitely tight. Those are plugged in. Plug in this side. That should be ready to power up once I plug the riser card into it. So we'll do that. Get the riser card out. I'll have to find it. It's up there somewhere. Not a super parts. Nah, nothing important. Where did I put that board? Just trying to find a riser card I made. This is definitely where we'll put it. So where can I find it? I'm sure we'll put it in this box. It must be here somewhere. Okay, what have we done with that? I seem to have lost the riser guard I made. Where the hell have I put that? Yeah, I'm definitely confused. It's not still on my desk, is it? The last time I used it. No. It must be in here. Some other ones. I kind of need this riser card to do this troubleshooting. Where the hell have I put it? Ah, there it is. Found it. Now we'll try and get him back in here. So this is a riser card I made for doing the 2002 repair, which will also work on this. Just a simple piece of variable perf ball, what you want to call it. Just a single line right angle header there, and a single line right angle header there, male and female. Alright, so that plugs into the headers in there, and this plugs into the module for the analog to digital converter. Now the problem is, I've just noticed, is this one's different design to the 2002. This one is stepped in a bit. That's inconvenient. That's not going to fit after all. On a 2002, the edge is right up against it, so you just literally just took it in. Well, damn it. Let's see what I can do to solve that problem. I just wonder if I've got some headers with big offsets on them. I mean, these are all dual ones, but dual one might be okay if I can get it to fit. And what I could do is put it in that way around. So I'll keep one side for the 2002, one side for the 2001. Yeah, it'll still work. Yeah, I think I might have to do that. I don't think I can use a single on that one. If I do a single, I don't think it's going to stick out far enough. Just try and line it up with the single one. Yeah, single's not going to be far enough out, I don't think. No, I have to use a dual and then step it in. Right, it's a bit of a bodge, but it'll do the job. Let's cut it off. I mean, I don't know if I can. Do that. I'm just wondering if I can. Because you can go either way around, doesn't matter, it's just straight through, right? So I could easily just run it around the other way. And just solder those on there, and I think that would probably work. That should be fine, I expect. Wasn't expecting you modifying the bloody riser card. Got to be careful and make sure it doesn't touch those copper fingers over here. That's fine, there's heaps of room there. That's fine. That'll work. That's definitely doable. So I'm going to do that. It ain't going to be pretty, but it'll work. Get my glass on so I can see what I'm doing. Don't get stuck in my gloves. Yeah, right. I'm just leaving this in because it helps pop it up. Yeah. A bit too much angle. Does need a little bit of angle, but not too much. I'm trying to make sure the back of the pin isn't sticking out too much with the board either. I don't want it catching on the other type. Just pop the bag out. Alright, let's sew this damn thing in. What I was planning to be doing? Boarding test gear to do the test. Anyway, doesn't matter. These pins are being a little bit resistant. Let's get some flux on this. Let's get the fan going as well. And where's my rod gun? Put it away. No, it doesn't reverse polarity because it's flipping over. I'll show you. So the board sits in like that. Okay, we're not turning it; we're flipping it. Right. So it's the same polarity. It doesn't affect that. If it is like a dual row, if it was actually 2 rows of headers in there, then yes, you'd be absolutely right. It will be affecting it. But it's only a single row. I'm only using a dual header to get the spacing, so it offsets it. That's why I'm using a dual row. Because I don't have any single row which is offset by that much. And because it's a straight through connection, it makes no difference. It should be fine. There's no like conversions between the pins or anything like that. I'm just going to solder some of these just to reinforce them a little bit so they don't move. It's not actually using them, but it's going to do it anyway. Still hold it up. Okay. Make sure there's no bridges. Definitely don't want any bridges on this. Maybe you're thinking it's 1:45 AM. Yeah, that happens, eh? No, you're right to question it though. Not wrong to question it. Let's check for shorts. If I get this straight. That bouncing up. You don't want to find a short after you plugged it in and used it. Okay, no shorts there. Just make sure there's nothing on the outside one. Yep, all good. No shorts. So that should be usable. Which I'll give this a clean before I turn that extractor off. Don't have to leave flux on stuff. Right. That should be good. Moment of truth, we'll find out in a second if recapping broke it or did nothing. I expect it did nothing. Well, hopefully it did nothing. So plug that row into there. Plug that into there. Make sure I don't get one pin off. That'd be kind of disastrous. Make sure it's not touching. That's all looking good. Right. Try it out in a second. And then we can actually get on to doing troubleshooting. This has taken us a long time to get to this point, hasn't it? Right, I've got this thing set up on the riser card. I had to modify the riser card, add a dual inline header there to space it off enough so I could plug it into that. It hopefully is all good. I guess we'll find out in a second if it goes bang. Hopefully it doesn't. Repair it. Hope you got your fingers crossed. Leave that plugged in. So I'll turn it on the rail over here. Right. Fingers crossed. No, still working. So that's a bonus. We haven't killed it yet. Now let's run a self-test just in case something's changed. It's very, very unlikely. It's not likely to have changed. I need to pull the front panel apart actually because these buttons need cleaning. I keep forgetting about that. I do need to do that. Let's see what happens. Just in case, or maybe something's worse. You never know. 309.1 is where it should start ears. Yeah. Same spot. Right, let's see what we got. See if anything's different. Yeah, 9.1. Yep. 2, 5, 6, 3, 10.1. Yep. Yep, no difference. Exactly as I expected. So that's fine. We haven't made it any worse. That's always a good start. Now we can start to diagnose the thing and actually figure out what's going on. Question is, where do we start? I think we need to look at circuit diagrams next and go from there. Yeah, the current measurement is the issue that we had at the very beginning before I did anything with it. That was the self-test failure and known issue when I purchased the unit. So that is not unsurprising. That's exactly what I expect. Actually, I need to put the current probe back in too. Yeah, still floating around. Need to tuck that in if I can. Let's put that away. Put that back in there. Current socket. And get it in. These tweezers just put away. I need to get them back out. That being not present wouldn't matter. It's not. It doesn't have any bearing on the self-test. So plug it back in. Come on. Trying to get the spring fed right through. This one's being stubborn for some reason. Don't know why it's being so damn stubborn. There we go. Right, now it's the spring. Here we go. Now I can put this bit back in. I've already swapped this one with the 2002, the one because it's got a bit of a break on it. So this one had a really nice one, so I've already put that on my 2002 already. So, right. Let's go look at circuit diagrams. You would start 310.1. I think that was the diodes, was it? Yes, we already checked that. That's those diodes we looked at before. That diode there and those ones there, that bridge, that was 310.1. That's what that was referring to. So I've already verified those are okay. Okay, off to bed. Good. Okay, good night. Thank you, dropping by. So that 310.1, that was those two diodes, like I said. So I've eliminated those. Now the actual manual says you should start at the beginning, because a lot of tests are built on the previous ones before it. Like 310.1, that is referenced to the same configuration as 309.1. So I was probably putting this in a video actually. So this setup for the tests it goes through, a lot of tests are built on the previous tests. So it mentions actually in the manual for the troubleshooting guide for this single repair manual, 310.1, which is what I was primarily thinking was a bad one, which I've ruled out already. That is the same consideration, that's the same configuration as 309.1. So it uses that configuration to run that test. So that test, those parts there tested okay, which brings us back to these parts in this first test. All these other tests are failing after it. They use some common parts like that resistor there, that chip there which is a switch, this chip here which is a switch, and I'm sure there's other subtle parts as well and things which aren't mentioned, but you'll be able to see in the diagrams hopefully what's going on, maybe. I don't know, they're not always that clear. So the first thing I'll be thinking of is these chips here, these switches. The resistor there, we can easily check that and just rule that one out, R591. That's easy to check, it's right there, and we can check it and make sure that it looks right. If it looks right, then we can ignore that one, rule that one out. the fact 399.6 isn't using R592 means I can probably ignore R592. That's probably fine, because that test isn't using it and it's still failing. But these parts are still used. P10.1 give me a good test voltage on the ADC. Potentially. There are a few steps which I do mention the ADC voltages. I think that a lot of them do actually have that mentioned in there. Exactly where that pin is, I'll have to figure out. But I know that these switches are in here are known failure points, right? So I might turn the solder sucker off for now, get rid of a bit of noise. Did I put that in without the fuse in? I think I did. I think the fuse fell out when I was putting it back in. Not putting the fuse back in again is kind of useless. Yeah, there's no fuse in it. Let's pull this back out. Try and pull this back out. Come on. Come on. Shouldn't be this side. There we go. No, I think. There we go. We'll put that fuse back in, then we'll put it back in. Hey? That would make much more sense. Here we go. Right. Let's go back over here. Oh, Night Siglent. I guess that's how you pronounce it, Siglent. I don't know. Thanks for dropping by. Okay, so we want service manual for this thing. Let's find it. It's easy to see it from down here. We want the analog board schematics. So, what page are you on? 2. So, the area I was looking at is this one, right? So you've got DC amp and AC amp coming in here. I'm not quite sure exactly where they come from, but then we've got the ranges here, 2 milliamps, 20 milliamps, and so on, switching through here. And then we've got that CR309, CR305, which you've already verified is okay. And then we've got the U323. Let's take his gloves off, actually. Gloves. You wear them so long for your hands get a bit yuck. So there's U323, which is one of the switches, and here as well, right? So this is one of the parts I'm suspecting. Also got 317 and 320 here as well, which may be something to consider. That looks like that's only switching that section. So 317 is switching a couple of ranges. Now, the issue was actually on all ranges, not just one range. So we know it's probably not that switch because it doesn't matter which range it's in, it's wrong. Test 309.1 should also give a good test voltage. Yeah. So I did see it mentioned before in other tests. I might even pull that page up at the manual and we can look at those as well. Although I guess you're looking at it already, but people probably aren't. So the fact that this is the ranging, and then we've got R591 here, 592 here, right? So these are the shunts, it's passing through all these shunts, and he goes through a different number of shunts depending on which range you're on. And in fact, they're all wrong. It could mean that this shunt here has got an issue, like R59, which you can't see behind my head. That one there. That one there, if that has an issue, that would skew all the ranges. But it wouldn't skew them by the right amount, because it's only a 0.1 ohm. So if that even doubled in value, because when I put in 1 amp, I was getting 1.9 amps, right? So it's double, quarter double. So if that were the 0.2 ohms to cause that big offset across that shunt, to cause that kind of shift in the amps range, well, 0.2 ohms is nothing on his other ranges. When you've got a 900 ohm resistor, it's nothing. It'll barely show up. Now, I am seeing a skew where the lower the range, the less of an effect it's having. I was seeing it down here on a 20 milliamp range. I think I did put in 20 milliamps. I was reading 30 or so. But that's still only a 9 ohm resistor. So, 10 ohms total. So to be out by 50% of that range, that needs to be 10 ohms down here. It's definitely not going to be like that. So I don't think it's a shunt issue. Fairly sure it's not, but we should check them anyway, just to be sure. Because that then rules that out. Now, if there was an issue with one of these switches, could that cause an upset? Not really, because in the 2 amp range, when I was putting 1 amp through it and getting 2 amps out of it, well, 2 amps red, that means it'd have to be skewing this by quite a lot. And by changing these ones, would that do that? Don't think so. No. Because it'd have to be losing that switch. That switch would have to be not shutting, not one of these ones staying shut. So I don't think that will work that way. So I'm pretty sure it's not a shunt problem, but I want to check them anyway, just to be sure. Switches I'm pretty confident are okay, because I went through different ranges. I went through 3 different ranges. I did 20 milliamps, 200 milliamps, and 2 amp ranges when I was doing the visual testing, and all of those are wrong. So if there's a higher up switch, it wouldn't be such a big influence on it. So I don't think that's the problem. So I'm sort of leaning towards switches. Let's have a little look around. So the switches that I left on notes over there, I remember 323 being mentioned, which is these ones here. And 320 was the other one I mentioned. I'm not quite sure where that one is. It's not on this diagram here. Must be one of the other pages. I think you mentioned 320. There's 320 here. That's for voltage switching mostly, but also some other stuff. Ohms cal. Don't think it's really relevant to that. DC amps is going through 320. So this one here. That 320 there is DC amps going through it. So that makes that one suspicious. That's a DG211. So U320 and U323 are prime suspects because these switches are known to fail. So it's a starting point. Although when I did the 2002, I checked those switches and they were fine. So, they don't always fail, but it's a known failure point. Alright, so 320, 323, prime suspects. So what else do we have in that list? 317, which we're looking at just now. There's 317 there as reference output. Don't forget DC volts is working. Resistance is working as well. DC volts and resistance are both working. We've got another 317 switching here. 4-digit. Divide by 4-digit, I guess. Could that be related? Don't know. But don't forget, although it's a single device which has got 4 switches in it, you can actually have it so that only one switch has failed at the 4. So it could be 3 of the parts are perfectly fine, but one's a bit flaky. So that's something to consider. It's for swapping rather than entering outlet holes, yeah. I mean, when I did the 2002, because the circuit board was so fragile, I didn't want to solder on that thing unnecessarily. I didn't want to do anything with it unless I really had to. So I didn't want to disturb anything or try and do solder stuff. So, I mean, 323 and 320 are prime suspects for failure, right? So, other things we can check as well, which are simple, is also got 322 is also mentioned. That's another one. That's that one there. That's AD input. But other stuff is working. And that comes through these other paths. So there's other stuff coming through this buffer. So because other stuff is passing through, DC volts works, resistance works. But you can probably say that buffer there is perfectly fine. There's probably nothing wrong with that. So I think I can ignore 322. It's also R344, wherever that is. I'm not sure where that is. Haven't looked for that yet. There it is there. Right. So it's just one of the ones that's mentioned in the repair guide, is that one there. Again, it's in a chain. So we'll check all these visitors down here. That will prove or disprove them. I expect it's going to prove they're all fine. And that really just leaves a couple of switches to look at. Does AC amps work? I don't know. I haven't tested that. That is a good thing to check for. It should be using the same path though. It's got detection circuitry and it comes through here. This switch here turns on the AC amps. So if DC isn't working, AC probably won't either. I think DC will be like the proving really that, yeah, if DC doesn't work, AC won't. I think that's how it's going to work. So I'm assuming AC doesn't. It fails safe test on AC. The AC calibration fails as well. So DC amps and AC amps calibration fails. That's what I got from descriptions. So I'm pretty sure it's not going to work. So I can test the switches. That's easy enough to check for. We can check for resistances. It's not completely conclusive, as I showed in a 2002 repair, that parallel circuitry can cause kind of weird resistances, or you might have parallel switches because they're doing different functions or the extra componentry switched in. So you can get some weirdness where it will be like, you might measure a short, but the other way around you measure 100 ohms or something like that, or 50 ohms. I think it's 50 ohm switching resistance on these, wasn't it? 50 ohm or 75 ohms, something like that. So you can get weirdness with that, trying to measure resistance across the switches. But it's a good indication of whether or not they're working. If you get one which isn't switching at all, then it's like, oh, okay, something's definitely wrong. But then, because you're measuring resistance through an active switch, which is on with voltage or currents going through it, it can actually mess up the reading for the multimeter. So I think what we should do is start looking at these switches first. Actually, no, let's look at the shunts first. Just roll those out because it's nice and quick and easy to do. And then we'll look at the switches after that. And go from there. So we want 344 is that set there, and 592, 591. Just quickly check those, shouldn't take much. Let's switch over and probably wait the camera, but no, the camera's still going. Thought it'd be off by now. Right, let's try and find these things. Where did I put my glasses this time? Yeah. Keep putting things down in different places. Alright, so we've got 591 is that one there. And then we've got this 344, which might be hard to probe onto because there's stuff in the way. And it's looking for 592. Mark on a 592. We'll get to it. Anyway, let's check the other ones. Of course, my cables are getting tangled up in other cables. That's what they do. More seasoning, just what we need. Okay. So let's just quickly measure the shunts and see what we're getting on these and see what we're getting, if anything, of importance. So we've got 591 here, R591. 0.3 ohms. I mean, my probe resistance is 0.2, right? So it's 0.1 there. Check the other leg. 0.3, yep. So that's fine. It's 0.1 across that. R591, that is fine. Now we've got R344 over here, but I'm not quite sure how easy I can probe onto it. I'm even not sure what the pinout is, but I guess we'll find out. There's one there. 1K, looks perfect. Another leg there. 99, yeah, that's good. Another one there, 9.2. So I think, I don't know, is there one more? Not sure if that's all the legs or not. I think that was it. 3 resistors in that package. I've got to try and find R592 yet. It's here somewhere. Cheers. I think it's the fumes from those bloody cleaners and stuff. Alright. Back to here. So 591's good. 344 is good. We've got to try and find 592. Where the hell is that? It must be there somewhere. Can't be too far away. It must be right there somewhere. Where is it? I don't see it. Where the hell is it? Does anyone know where that resistor is? It's not like on the back of the board, is it? I would have thought it would be a precision resistor though. So I'd be surprised if it is. I would have thought it must have been around here. I mean, it must be. I'm definitely not seeing it. No one can see it. Oh. I've got to switch the screen back. Yeah, okay. I suppose I should do that. Yeah. Alright. I'll get really close with the camera and you guys can tell me if you can find it. Didn't know you can see it. $592. We're looking for 592. There's 591. We've verified that one. We've got 344. I mean, it's in between these two resistors, right? So you think it'd be in between these two resistors. I'm starting to wonder if it's a service mount one in the back. Okay, well, let's see if we can find another way of measuring that, shall we? There must be some way we can find it. So let's look at the circuitry. 592 is between 591 and 344. So if I measure between 344 and 591, I should be able to measure that resistor, shouldn't I? Even if I can't find it. Yeah, the 4-leg resistor there, that's 591, it's a 4-leg resistor. So if I measure, say, from here to here, 1.2 ohms. There we go. So there's the 1 ohm resistor. It's there. It's obviously there somewhere. It must be on the back on a service mount or something. Could be. No, let's just show that bit in the video. So should I null these out? Can I null these out? Can I null these things out on this thing? Actually, that's a good question. I'm sure I can. Anyway. So I can't find that resistor, but if I go from this resistor here, 591, through to 344 over here, we get you 1.1 ohms. Now don't forget I've got the lead resistance here of about 0.2 ohms or so. Alright, so that gives us 0.9 ohms. And what we're looking for? 0.91 ohms. And that's what our 592 is. So the resistor must be there somewhere, and it's obviously good. So we've eliminated that. Even though we can't find the damn part, we've eliminated it. Okay, so now the shunt chain is okay. The shunt's good. Right, so we eliminated the shunt. Now we need to look at switches. Which switch should we look at first? I'm thinking 323. Thinking 323. We'll look at that one. I mean, that resistor up there, I don't think it's up there, is it? That's 607. No, it's not mentioned in that one. And that's just a single film. It's not piggybacked. This one here is piggybacked. That's a bit different situation. So, anyway, that's all right. It could be a service mount one on the back. It's entirely possible. Right. Make sure it's all okay. We're just lodging things and moving things around. Switches. 323, where was that? It's right there in the middle. So I'll just check the whole device and let's see what we get. Yeah, 591 is this thing here. It's a 4-leg resistor. 0.1 ohms. So 591's fine. It's 592 we can't find. .592 is the same. Yeah, okay, well, I'm not seeing it though. I found 593. That's not what we want, is it? That's a service mount. Anyway, we know it's testing and good, so I don't really think we need to look into that one too much more. It would be nice to figure out where it is, but it seems to be testing okay. Right, let's power this thing up and look at these switches. See what we're getting. Measure resistance across these switches. So we're running. We are running. So try and get all this right. I can see it as well. So 323 is there. Trying to remember the pinouts. I think that's a switch there. 29 ohms. Reverse them. 29 ohms. That's a good one. And it's closed. That one looks like it's probably open. That's open. That one's probably open. And there's probably open. Okay. So we've got one switch which is closed in theory. So let's measure voltages. There must be a test point I can use for ground somewhere. Or I can probably use a casing, it's probably safe. I think I can use the casing, I'm pretty sure I can. Right. We'll find out. That's low. That's high. That's high. That's high. Yep, okay. So those switch states match those power states of the switches. So on that one, let's change to current, which we know is given trouble. And let's check our switch states again. Pin 1 is low, so that's on, that's off, that's off, that's off. So nothing changed on that switch. Those switch states control switch states didn't change. So we can probably ignore that one then, because nothing changed, go into current mode. So let's look at 320 then. So pin 1 of 320 is off. Pin, is that 7? 7? It's 7, isn't it? Whichever pin that is, I don't know. Might be 7 or 8, I can't remember. That's on. Next one's off. That one is jumping around. There could be auto zeroings turned on. It's possible. That's interesting. Let's try auto zero. Check for that. Where is that? I've forgotten where it is. Don't know where that is. No. Try and remember where it is. Reuse it. Oh, push to exit instead of exit. Instead of enter. Push the right button. Auto zero. Disable auto zero. Let's measure that one again. Still jumping around everywhere. That's interesting. If auto zero is turned off, let's just do manual ranging. Still jumping around everywhere. Right. So I'm just probing around. I've just probed already on U323. It looks kind of okay. Haven't seen anything obviously bad there yet. I'm just probing U320, and I think it's pin 14. 16, pin 16. That's the trigger pin, that's the control pin for one of the switches. And it's jumping everywhere. Now I've turned off auto zero, I've manually ranged it, and it's still jumping everywhere. So that's a bit suspicious. I'm not quite sure why it's doing that. Let me check on the actual switch connections it's doing. And it's jumping around as well. That makes me suspicious about that switch being bad. Maybe it's got an internal short. It could be annoying, it could be fine, it could be completely normal. But I'm suspicious about that. Yeah, the switch has not changed, so the fact DC volts works and DC current doesn't, and that switch didn't change states, probably confident that switch is alright. There's nothing there that looked like it's bad anyway. The switches that are open, and the one that's supposed to be shut was shut on that 323. This one's looking suspicious. So let's measure the resistance across this switch and see what we get in here. I'll try and get it so you can see what I'm doing as well. I'll try. I'll probably have my hands in the way though, that's the only problem. Is that going to be alright? Maybe. Let's try and show you what I'm doing here. So I've gone to resistance mode. I'm going to try and measure across each switch. So let's go between pin 2 and 3. That's going crazy. It's possibly completely normal. And the other polarity, yeah, probably completely normal. Could be. You get all sorts of weird readings across switches, but I'm looking for anything that looks obviously wrong. That's looking fine that way. That's good. And the same that way, so that switch there is closed. That one there is jumping around a bit. Could just be circuitry affecting it. check it this way. Get onto it. Yeah, that's right. And this switch up here, which I think is switching on and off. Yeah. So the fact I've turned off auto zero, and I'm just going to reprobe this one here, which I'm looking at. The fact I turned off auto zero and manually ranged it, and it's still trying to change something here. I would not have been expecting that. That switch there is stable. That switch there is stable, so yeah, that's fine. So I'm still suspicious about that one. Not feeling any heat. Let's have a look at what those connections are doing, in case there's something simple. It may be fine, but I'm just suspicious it's changing around. So that's pin 18 of 320. So DG320 pin 18, just got to find it first. Might be on the other diagram up here. 320. We'll try and find the damn thing. Let's try and find pin 18. Because you've got 1, 16, 9. Where's the other one? Maybe it wasn't the other diagram. Maybe it was down here. I just missed it, maybe. That's 323, that's 323. I don't know where these other diagrams are going. I'm just looking for it. Let's go up another level, go up to this one. There's 323 there, there's our 320s there, looking at before. So where is it? Wondering what it's doing. It may be completely unrelated, it might just be a spare switch that you're using for something else. Not actually running through the analog path. Display said no change made. In what? Did I not actually turn off that then? We should look at the comments more often. Menu, general, auto zero, disable. Okay. Measure it again. But those dodgy buttons throwing me, thinking I pushed it right, actually didn't. No triggering means it's doing nothing. Okay, maybe it was still auto zeroing thing. Maybe it was still doing it. Let's turn the trigger back on. Yeah, okay, right. Okay. Okay, that's fine. I'll mention that in the video then. I thought I turned it off. Well done, good spotting. So I went down a bit of a rabbit hole then. I tried to turn off auto zero, but I think the button, I pushed the button, it didn't actually register, and I didn't actually turn it off. So it's now definitely off, and if I measure on pin 18 of that device now, it's stable. So I've also turned triggering back on again, so it turns triggering off when you do that. and that's sitting there now. So all those ring was doing that. So not a short on that device that I can see then. At least nothing obvious. No, I think I must have missed push that button, because it was definitely not off. It was definitely on. So so I think when I came over to come to here, I think I only got as far as normal. I don't think it actually came over to disable. Unless I did something else weird or something, I don't know. But anyway, that's right. So now it's not doing that. Let's check the switch itself. The switch is currently closed. There you go, 29 ohms. Okay, so the switches are doing what they're supposed to do. Let's check this other one which is floating around before. That one there. Yep, that's not floating around anymore. So switches appear to be kind of doing what they're supposed to do. Yeah, that's why I said no change, because it didn't actually select the right one. Right, and I left it on the wrong screen. That's awful. Okay, so back to the list. Let's get a pen. Let's cross out the things we verified. The resistor, check. That resistor, check. That resistor, check. 323 appears okay. 320 appears okay. On the surface, no obvious faults. So we're now looking at 317 and 322. 322 is the output, like I said. I think that's probably fine. Where was that? That was that one there. That's the buffer that goes to the ADD input, right? So I think that's used for everything. And it's got like divider chain here as well. So these are dividers. So 322 is probably okay. Unlikely to be a failure. Unless the dividers have got a problem. Maybe the dividers aren't working quite right. But I thought they were sharpen other things as well, not just the current range. So 317 is the next thing we've got to look at then. So we've got one switch here. There were more. I did see them. Where were they? Maybe on another door. Maybe up here somewhere. Or the other one. Downwards. Here. Right, yeah, 317 is switching in here. So maybe that one? Because you've got a DC and AC coming through here. Time to break something. No worries. Thanks for dropping by there. Hopefully I'll get this thing fixed and you have something to watch later on. Maybe. Replace them all. Yeah, well, you know. They're not cheap, these switches, though, are they? Not that cheap. Anyway, yeah. So that's the DG41. So U317. I'll look at that one next. Cheaper than working. Yeah, well, it's true. Yeah, cheaper working. Yeah. But I like to try and narrow it down if I can. I'd rather just figure it out if I can. I'd like to prove it. I don't want to change stuff and go, okay, something was wrong. I mean, yeah, sure. I don't think you're wrong in saying what you're doing. I've seen you do repairs plenty of times and stuff more complicated than my working. So, you know your stuff. Anyway, here you go. Enjoy breaking whatever you're going to break. and I'll carry on trying to break this. Alright, let's look at 317 and see what's going on there. I just like to find a definitive fault, you know, if I can. In fact, I'm going to have some lunch quickly, and my stomach's growling away. It's 22. So I've been going for nearly 6 hours. I'll eat this and we'll carry on. You set over 6 hours, yeah. Good on you. That's commitment. Alright. Well, 317, we'll look at that. I'm trying not to drop crumbs into it. Two 117's right there. So I'll get the thermal camera out, just in case there's anything which looks a bit dodgy. Should probably do that. Do a heat check. Mm-hmm. Well, there's nothing horrendous in there. Nothing different to what I expect to see. The hottest thing as a reference, as you expect. Now there is a device there which is a bit warmer than the rest. Not much. It's only 47 degrees, not that bad. So there's nothing really standing out as being bad like that. Yeah. Looks fine. Infrared doesn't show anything as being a problem. Well, yeah, the cow factors could well be completely screwed up. U323 is the first device we looked at, and it appeared okay. It didn't switch between DC volts and current though. There was no switching going on. Should it be? Well, I was just checking for anything hot. Like these switches, when they fail, they do tend to run a bit warmer, right? So I'll just have a quick look to see if any of them lighting up, and there is a little bit of warmth in them, but nothing really there, nothing out of the way, out of the ordinary. So there's nothing really showing up as sort of flagging as, hey, this is a problem. Yeah, okay. It's going to take some thinking, I think. So 317 is what I'm going to look at next, just to verify that it's switching and doing what it's supposed to do. I mean, if it switches on, and I'm seeing, like, say 30 ohms, is what these ones are showing, aren't they? Around 30 ohms. Then that switch is closed and it's working. And if they're more than 30 ohms when they're not, then they're probably okay. So that's basically what I'm checking for, is that the current state in this mode is correct. We can always go through and check manual ranges and see if anything changes from ranges. We can also go through and check the shift registers in case the switches are being controlled. I could say it's probably, if it's a shift register problem, the switches could be incorrectly controlled. So the switches are working correctly, but they're not being controlled correctly, which means the switches will test fine, but they're not changing. That could be something which is happening as well. So checking the shift registers is something we could also look at. There is information about how to do that, and the actual states are in each mode and stuff. Anyway, 317. It's this chip here. I'm measuring resistance. Let's do voltage first to see which ones are on. That one's on, so pin 1 is on. Pin 8 is off. Pin 9 is on. Pin 18 is off. Let's say pin 8. 16 is off. Yeah. Get numbering right, Jesus. Okay, so what did I say they were? I've forgotten what they are. That's measuring 19 ohms. Reverse the probes. Reversing the probes is important. Still 19 ohms. Did I say that was on? I've forgotten. I think it was 1 and... yeah. 1 and 9 were on. The others are off. That's right. So that measures correctly. That's looking promising. I'll just record a video on it, shall I? So I'm just probing on U317 now, making sure it's all good. Pin 1 and pin 9 are low, which means those switches are active. So I'm just probing around them right now, just trying to see if I can find any issues. That is high resistance, so that's fine, that's off. This one should be closed, 15 ohms. Other way around, 15 ohms, that's good. This one here should be open. Looks like it is. Yeah, so can't fool that switch either. So far I'm not getting very far. When I was at ACAL, 6 and 7 should be closed. So where are they right now? Let's have a look. Right now, they're open. They're open right now. It is possible to go into the ACAL and actually test each step and check the switches themselves in that step, because as soon as it's done that, and we kind of run out of stuff now, let's go and do that, shall we? Menu, test, built-in test, manual. Probably can't see what I'm doing. You want test number 309. Enter. Single. Continuous. Let's do continuous. No, let's do step. Right. So that's what we want. So we've got 309.1 stepped, and it's now in that test state. So it should be holding all the switches and all the latches in that test position. So we can now measure those switches again and see what we're getting. Right. Actually, I should probably cover that in video. So I've just gone into the test mode, done manual test, told it to do the 309 series and stepping. So it does, it goes to the first step, it does the first test, puts everything into those states, like all the switches and stuff, and it will sit there waiting. Okay, so it means you can actually go through that step and check to make sure all the switches and stuff are where they're supposed to be, and then you can go on to the next step. So now I've done that, let's have a look and see what we get, and let's see where these electronic switches are sitting at. Okay, so we re-verify those. So let's go back to U323. Pin 1 is off. Pin 8 is on. Pin 9 is off. Pin 16 is on. Right. So these should be open. They are. These should be closed. They are. These should be open. They are. And these should be closed. They are. Right. So that's U323 in that state is looking good. So let's check the next one, which is 320. We'll check that one as well. So pin 1, it's off. 8 is off. 9 is off. 16 is on. Let's verify those are in those correct states. Yeah, getting a resistance there. Swap the probes around. Still a resistance. So between 2 and 3 we're getting a resistance on U320. It's 2K. It may or may not be an issue. Might require further investigation. This one here's 230 ohms. Both ways. Okay, so 320 is suspicious. I'm surprised about those readings being that low. Could be parallel paths. Next one looks alright. Swap the probes around to be sure. Yep. Let's do it again. Yep, definitely nothing there. And these ones here should be closed. I'll get onto the probes. Yep, that's closed. So between 2 and 3 and 6 and 7 on U320, I'm a little suspicious. Might have to look at the diagram to see what's going on there. And then we got 317. So pin 1 is off. Pin 7, well, pin 8 is on. 9 is off. 16 is off. That is indeed off. That is on. This should be off. 85 ohms, looks a bit low. The way around, 86 ohms, also suspicious. That one is looking open as well. So, yeah. So 317 between pins 9 9 and 10 is low. So we've got two chips here I'm suspicious about. Just because there should be much higher resistance there. It could be external circuitry. But I'll look at circuit diagram, see what we can see. Do I need to write these down? I think I will, because I'm going to forget them. 317 pin. I'm already forgetting. I'm already forgetting. Bloody hell. 6 and 7 was it? And 320 was 2 and 3 and 6 and 7. So 6 and 7 or 317 should be the current path going through it. So that's interesting. 6 and 7 is going through there. I'm in that range though. So maybe that's okay. Maybe self-test isn't worried about that. Okay, let's look at 320. That switch was... Let me check. Let me check that one. I might be losing myself here. So pin... Yeah, pin 8. And I can't see what the hell I'm doing again. 317. Pin 8. And let's do a voltage measurement. Hold on. I'll come back. I know you can't see what I'm doing right now. I'm going to come back. Okay, that is on. So which was the one I was looking at then? Was it 1 and 2? Hold on. 2 and 3 I mean. 6 and 7 are on. Am I thinking about the wrong pins? Yeah, I'm thinking about the wrong pins. 9 and 10 is what I'm looking for, not 6 and 7. 9 and 10. Yeah, right, 9 and 10. 317, 9 and 10. Because 6 and 7 should be on, and they are. What's 9 and 10? I might get these numbers wrong. Sorry, 10 and 11. 10 and 11 are on. A showing a resistance path. Okay, that's fine. There is actually a resistor there. So it is actually 10, not 9 and 10. That's 10 and 11. I'll get these bloody numbers right. So that's 10 and 11. But there is a parallel path there, so that's perfectly fine. Yeah, because there's a resistor there. That's going through here with that in parallel. So I think that's fine. So I think 317 looks alright. At least those pins look alright. So 320. Where were they? Down here somewhere. Was it up somewhere? Up somewhere. Right, 320. Pins 2 and 3, which is AC volts and amps. Okay. And 6 and 7. Where's that? Where is that? So there's obviously a parallel path from this to this somewhere. Because it was showing a resistance there. I might just go and remeasure that resistance. I've forgotten what it was. U320. 2 and 3 is 2.1k, and 6 and 7 is 230 ohms. So 2.1k is probably not that much of an issue, but 230 ohms is certainly suspicious. So we've got to try and find out where 617 is. Or 6 and 7 from U2 320. Just got to find it. Not sure where it is. Oh, there it is. AC amps passing through. Here. Okay. So I would expect that to be on anyway, but there must be a parallel path somehow in here as well. But it could be a parallel path. Or is it that it's leaking and so it's got something else going on which shouldn't be there? I'm just suspicious about that number. Measuring the voltage can be helpful. I've done it before on other ones when I was doing the 2002, but it can be inconclusive because you might get like 0 volts on both sides. And it's like, well, is it conducting or not? Or you get 0.2 volts or whatever it may be. I like to try and measure the resistance across it because I'm trying to see if the switch resistance is opening or closing. This is why I also swap the polarity of the probes. So by swapping the polarity around helps to reduce any effects of parallel circuitry. Yeah, so that one maybe should be on. I might just retest pin 8 again in case I misprobed or something. I think no, it did measure 4.2 volts, so it was being turned off. So why am I getting resistance through there, which is parallel resistance? 230 ohms. It can't be coming from this path because it's too high resistance through there. Don't know. Sort of fly flying around, little trip fly. Don't know where this come from. I mean, the switches that are active look right. I'm just suspicious about this 320 right now. There's another thing we can do. If I turn the power off and see what resistance we get with the power turned off. If it's still the same, I'll be very suspicious. Because that should be isolating this. I don't know where this comes from, or that one. I don't know where they come from. The circuit diagram's a bit hard to follow in some ways. I haven't found where those labels go, which isn't that helpful. I mean, they must be in there somewhere, unless I haven't found them yet. We've got amp in here that may be related. There's amp in there. Amp in here. Yeah. I'm trying to fix the Keysight 2001 7.5 digit multimeter. That's what I'm working on today. Just trying to track through some of the circuitry to try and figure out whether there's an issue with one of the electronic switches. There's a few of them. Like there's the AC amps one there. That comes from U510, which is another switch. So the biggest, you can probably see it on screen, just there. Just trying to see what else is around here. Protection. There's AC amp there, the control line. Might be spread further than I thought. It might be coming to this sheet as well. Still trying to find the flag for DC amp. I want to see where that's coming from. Haven't found it yet.
Girl could starve to death waiting for you to finish.
There. Just been handed some food. Yay. Yeah, I'd like to find a DC amp flag, but I can't see it in here. It must be here somewhere. And this is just the cover page up there. So I want to find out where that DC amp's coming from. Because then I can understand what that circuitry is doing a bit better. If you see it, tell me. Must be here somewhere. So there's DC amp there on that side. Is that all there is? Go between here and there. I wonder if that's all there is. Go between that point and that point. That's the output to the buffer. So is that linking this to the buffer through here? So what's the AC amp doing there then? That's probably that one there. AC, oh, it says VA, doesn't it? Is it the same? It would kind of make sense. Inconclusive at the moment. I'm not quite sure. I mean, it could be a parallel path thing, because if that's across that same switching, like if that is the AC amp coming through here, then you've got this path here. It's still coming back to U320 though. 320 is both of those. That's 320 as well. Is it worth just replacing that part? Maybe. Maybe. I'm going to eat this burger that my wife just brought in for dinner or lunch. Look at the circuit diagram. Tell me what you think. I'll even mute the sounds, you don't have to hear me chewing. Right. Just going to go and have a quick pee. I'll come back. Right. Back again. Now, where do we go from here? That's the next question. Where do we go? So, it's a bit inconclusive right now about whether or not there's a leakage through U320 in pins 6 and 7. There may or may not be. Seeing as DC amps, or DCA, seems to be coming to here, which will pass through this switch, which is between 14 and 15. Now that was turned on or off. Is that on or off? I mean, if that one's inverted, maybe? Let's have a look, see what that one's doing, see if those are actually active or not. Because if they're not active, then it can't be coming through here, can it? Or it shouldn't be coming through there. So let's just recheck that one. I know I did look at it, but I don't remember what it was now. Let's wake the camera back up because it's I'm asleep. Okay. So we're looking at which pins? I've forgotten. Okay, pin 16. We'll check see if that's on or not on U320. Now I need the glasses because I can't see the small part legs that well. No. 320 pin 16 is, I'm in resistance mode. I'm going to see voltage first. That's on. Okay, so that is an active path, and we've already verified that was working, didn't we? We already did that check. So there is definitely something coming from that path there. Yep, at 29 ohms there. So it's whether or not that's affecting this chip over here or not. Was that one there? Was it those ones? Which ones were we looking at? 6 and 7, wasn't it? Yeah, that's what I'm suspicious about, 6 and 7. Right, let's go to the next step in this chain. I'll push the button. Right. 309.2. Let's do some more checks with that one because this one's also failing. Let's go around with this one. do some tests. Let's do 323 first. So that's off. That one is on. That's off. That's on. So that means 6 and 7 should be closed. They are very closed. In fact, this reverse the polarity. Yep, that's good. These ones here also closed. These should be open. It is. And on that one there, if I go onto it, it is. Next one. Back to 320 again. That's off. That's off. That's on. That's off. Right, so those should be open, although you might get that 2K there. 3.1K now. That's changed. 1.2. It's not the same. We get that 230 across there before. Something definitely changed. 30 ohms there. Nothing there. Okay. That one looks alright. So there must be a parallel path on that switch. I don't think that switch is bad then, because something else changed. That switch didn't. But the resistance across it changed. So there must be some other parallel path which is switching. So I think that device is probably okay, that U320. So I think 323, 320 are probably alright. So let's check 317 again. So pin 1, that's off. 8 is off. 9 is on. 16 is off. So there's only one switch which is on. So this should be off. Yeah. That should be off. Probably 1K seems very high. Both the same way. Right. This one here should be off. And this one should be on. 15 ohms. That's quite low. Could be a parallel path or something else. 16 ohms. So that looks alright as well. Inconclusive. That's not what I like. Right, so the where is it? This one here. So I think that's okay, because that did change the resistance when we changed the next test. So our test must be switching on or off something else which is affecting the parallel paths onto that device. What that is though, I don't know. So I'm not convinced about those parts being bad. So I think I've eliminated all the main parts, which is annoying. I think U323 appears to be working correctly, 317 appears to be working correctly, and 320 appears to be working correctly. At least the devices themselves. Yeah. So I need to go to the other page of the manual, or the other manual, the repair manual, which has some other information in it, and we'll look at that. Repair manual, which one is it? That one there? Yeah. Just try and find the relevant information, and I'll chuck it on screen. Oh, that's not the right one. This one. Right. Right, here we go. That's not the right one. This window You don't need to see the window of my bloody stream. You're already watching it. Right. Here. So it properly. It's not doing it properly. Here we go. Alright, so this is the test it mentions here. So it's got current sources, or ohm sources. You want to think about it. And it explains what it's doing here. I just want to see if there's anything I've missed in this description compared to what I've been looking at. So I should be able to measure 89 millivolts at the A to D input in this test, which is what Dave mentioned before. Parallel paths, well, they're kind of broken up across diagrams, so there is something there. It's not completely clear because it does just jump off like this AC amp one here, ACA. And the DCA, there must be some path there between those where it switches between the two different current sense methods for each one. So there'd be like an IMS converter or something, I don't know, but I don't know exactly how it's doing it. But there must be something there which will show up for that. But, we checked all those parts there, and so far we can't find any issue. So if we measure at the A to D input, on test 1 we'll get that voltage, and this is all the shift registers, so we can also go through and check all the shift register logic to make sure these are actually correctly set. That could be something else we could do in case there's a shift register issue. I mean, we verified the switches appear to be working correctly, but are the switches being controlled correctly? That could be the issue there. Shift registers also known to fail. It's 4094 shift registers, that's what I believe they are. They're known for failure as well. So it wouldn't surprise me if it could be one of these which has gone bad. You know, a stuck bit or something, that's all it'll take. So that's also a consideration. But right now we're on a 309.2 test, and it's skipped onto this one, so this is one we're on now, we've stepped into that. So it should be same stuff, same configuration mostly. Should be getting 98 millivolts on the analog to digital input. So let's see if we're getting that. Yeah, those same parts listed there. So let's find the AD input, and we should find 98 millivolts. Let's look, see if we can find it. So what I'm going to look for now is the voltage going into the A to D. The A to D does have a hopefully a marking on there somewhere. I'm not quite sure which pin it is, but there should be a pin here with 98 millivolts on it, which is the A to D input. Now unfortunately I've got the riser card on here, so I can't just see which pin is which. So I'm just going to measure them all. And hopefully one of them's got 98 millivolts on it, because that would make sense. Okay, so we'll do that. I think I can... Yeah, I'll just shove this on the casing, that'll be fine. So let's just probe them all and see if we get one with 98 millivolts on it. Because if we do, then we know that's working. If we don't, then it's not there. Well, it's not there. Okay, so let's look at there's a buffer. I see. Let's check that out. But I kind of ruled that one out. That was what was that IC number? 322. Let's look at 322 pin 6 because that should go to the ATD. Maybe I've got an issue there. You weren't reading it or something. U322 should be easy enough to find. Must be around there somewhere. There it is. Okay, pin 6 of that device. That's an LT1007. I have some of those somewhere. So pin 6. Yeah, we're not getting there, are we? Right. So what are we getting on the other pins? It's supposed to be a ×1 buffer. So pin 2 and 3. We need to look at those ones. Let's see what we're getting there. Pin 2 is 13 volts. Oh, sorry, that's pin 2. I'll go on the right pins, eh? It'd be much better. That's pin 2 is 0.03. That's pin 3. And that's pin 6. So there is indeed buffering what's going in. But what's going in isn't right. So that's interesting. Let's check voltages. Minus 13 volts. That one. Plus 13 volts. Yeah, okay. So they're present. So the voltage going into that buffer doesn't look right. Because it's supposed to be doing 98 millivolts. It isn't there. Pin 3. Oh yeah, okay. So pin 3 is... I don't know, it's either that end or that end, isn't it? Not that one. That one. Yeah, there we go. So the buffer appears to be doing the right thing, but the voltage going into the buffer is not right. So it's before the buffer, which is kind of what we were suspecting anyway. Pin 2 is the loop, the feedback loop. Pin 3 coming in is a signal. So this is where we're looking here. So we're getting that 0.3 volts, or 0.03 here, 0.03 here. And obviously that's the loop, so that's amplifying by 1, which is what it's supposed to be doing, that's correct. There's a mux here. I'm not sure what that's doing. Divide by 2 times 5 times 50 times 1. Okay, right. So anyway, the voltage coming in is wrong. So where is that coming from? Is that from here? Or is it from somewhere else? So that DC amp one is there, right? So I would imagine then that we should be seeing the voltage through here somewhere being injected from another device Maybe that one. Yeah, I'll look at the voltage. Yeah. So I think that DC amp, or DCA 15, I think that is coming from here. So I think that one there, so pin 7 of U320 and pin 15 of U320 are joined together. That's what I think. So U320 pin 15.03 and pin 7 is what, 7 at 0.03. There we go. They do seem to go together, or at least at the same voltage. That pin there, yeah, and the other pin, yeah, it's the same. So those look sensible. There I test things as going. So where's that voltage coming from? It's obviously injecting it to try and detect itself, isn't it? It's probably trying to divide a known voltage down. But where does that come from? So I think it's coming from here somewhere. You've got the amps one here as well. So where's that injecting that voltage from? That's just protection circuitry. We can probably forget that. Ohm source, did mention ohms, didn't it? Is it coming from the ohm source? But ohms seemed to test okay when I worked on it. When I did the testing on it. After migraine night, yeah, they suck. I hate migraines. I also suffered with them. Knocked me out for days. I mean, is it bringing it through here? We've got this mux here. I'm just not sure it's coming through this way or not. If it's using the ohm circuitry to generate that. Yeah, that's kind of what I'm thinking, is it's ohm source. But when I did the ohms testing, it worked. Like I tested the resistance ranges and it worked fine. It was quite accurate even. So I'm puzzled by that, because I would have thought that I've kind of eliminated an issue with the ohm circuitry already. I'm definitely puzzled. Because I mean, that would come through here, wouldn't it? That switch there, but then so would the ohms resistance stuff. The ohms stuff, the resistance range controls will also come through here as well, wouldn't they? Potentially. That's pin 8 of U323 and 6 and 7. Let's go and relook at that. And you couldn't see what I was looking at because I forgot to change screens. Anyway. Professional YouTuber. Yeah, sure. U323. I'm trying to get so you can see it, maybe. I don't know. I think you can see what I'm doing, can you? No, not really. Alright. 323 pin 8 is that one, which is on. and resistances at pin 7, well, voltages at pin 7 is, I did see it jump for a second then. Pin 6 is at 0.3. And pin 7, I did see it jump to 0.8 for a second. That makes me suspicious. Was it just me slipping a little bit or something? Anyway, you get significantly more on that side than you are this side. It's double the voltage, but it's still way down. So where does that come from? It comes from down here somewhere. Let's follow that circuitry and just see where that's coming from. Because I would have thought I'd be getting at least, 90 milliamps, 90 millivolts or something down there. And I'll switch the screen this time. So yeah, I was looking here, and this pin here, pin 7, is definitely higher voltage than this one. That's 0.03, it's 0.06, and the switch is turned on. Now, is there something this side dragging it down? You've got these diodes here, protection diodes, which limit maybe. No, that shouldn't be active anyway. They should be turned off anyway because I'm on these lower range. So I don't think, even if that was shorted, I don't think it'd really have an effect. Because these should be off. Anyway, so I'm not getting the right voltage here. Voltage across shunts, yeah, and it should be it should be 89 millivolts. So either it can't produce enough current to go across a shunt, or there's an issue with it loading. Things we've already verified these shunts are okay, right? The actual resistors are good. We verified that. So I'm not quite sure yet. I mean, if it's excessive loading, then that could drag it down. But what's going to be loading? I mean, we've checked that diode, and we checked that diode bridge. They checked fine. So we've kind of eliminated this as being alright. Yeah, but pin 7 would have been higher voltage, wouldn't it? That would have crept up, because that if that was a higher resistance, that would have been like effectively added to the shunt resistance, so the voltage would come up, wouldn't it? So it was slightly higher, but it's still not as high as it should have been. If this was higher than the 0.89, well, the 89 millivolts is supposed to be getting, then I'll be going, yeah, okay, we've got an issue here. It's getting a voltage drop through here because it's adding resistance to the circuitry, right? But it's not. It's still lower. So either something in here is loading it right down, or it's not being generated correctly over here. But I'm not quite sure if it's coming from this or this section. Probably this section, won't it? Not sure. What if this read relay here is giving trouble? That switching needs to, whatever that is that owns coming in here. I'm assuming it's coming in, not going out. Could be either way. If that read relay is playing up, maybe it can't provide enough power through these. Let's check to see if K300's on. I think I can see the pins underneath it. Let's have a look. I can see the pins underneath it. Let's just probe on here. One pin there. That's 5 volts, well 4.2 volts. And that pin there. 4.2 volts. That relay is currently turned off. So there's nothing going on there. That should be open. It is. So read relay, we can ignore that. Nothing to do with that. And the camera just turned off because it's bored. Ah dear. So it's not a read relay because that's not energized. Should it be? I was wondering where that source is coming from, because if that's turned off, unless that's the output line, trying to understand, maybe it's coming from there to there to there, maybe. Current sources aren't something I'm good with. It's funny what these things are doing. Yeah, I'm not sure. I'm kind of at a loss here right now. We're obviously seeing something which isn't right. We're not getting that right voltage there, the correct voltage there. Let's go back to this page. So that was the same, wasn't it? 89 millivolts. Yep. So 89 millivolts should be there. Should be 89 millivolts here. Oh, sorry, 98 millivolts here. So that's 89. That's 98. Next one should be 92. Let's just step to the next step and see if anything changes, eh? Wake the camera back up. So, next step. 39.3. Measure on pin 3. 1.7. Oh, the voltage. 0.2. Yeah, that's no better. And pin 6 of that. Yeah. Is interesting. Pin 6 is 100 millivolts. Okay. Hold a minute. It is there. So that one is there. How come I didn't get the first time around? Did I measure the wrong pin? Am I supposed to be getting what there? In this mode, it's supposed to be getting 92 millivolts. So right now, we're measuring too much. It's the 20 milliamp range. Which does kind of go in line with what I saw. Let's go to the next step. 309.4 should be measuring 10 millivolts. Next step. Should be getting 10 millivolts here. We're getting 4 volts. That's definitely not right, is it? Yeah, that's 4 volts there. Getting 0.1 there. Well, that's interesting. That's very different. Why is it doing that? It's supposed to be on 50 times gain. Okay. So it is doing 50 times gain. Based on what's going into the input. The input is 100 millivolts. So what we're seeing on the output is correct. 50 times gain is right. But the voltage is way off. Why is that so far out? That's 9.2 milliamp ohm source. Through 323. Directly protection diodes. Interesting. Yes. Okay, I pulled low. That one there, yeah. None of the amp switches or FETs are closed. I'm not sure about the 10 millivolts. I'm certainly getting significantly more than that. That's interesting. That may be a clue. But interestingly, 309.4 wasn't one of the self-test errors. It's trying to measure trace resistance between common at the own source and common at R591. So here, it's trying to measure from here to the common over there. The fact that voltage is way higher than I expect it to be makes you think that the resistance is higher than it should be. But then the first test we're doing looked like the resistance is lower than it should be. because it looked like it had been dragged down. But if the resistance is higher on this side, causing a voltage drop, where exactly is that bloody source coming from? Is it coming from this mux, or is it coming from here? Not sure. Yeah, I'm not sure. What is that path there doing? I mean, that's a mega ohm resistors. You won't get much current through those. Not the kind of current I was trying to push, so I don't think it's going to be coming from there. Yeah, I don't understand this bit of circuitry well enough yet to make a decision about it. Things we know that read relay's open. And there's no power going to it, so it's not actually trying to close. I'm just not sure if it's coming from here or from here, or whether this bit works in conjunction with this, because you see these that's 750 ohm, 750 ohms, 7.15, 78.7, 1 meg. It's stepping up through each one, so these are be different current source values. So be lower current sources with lower resistance, high resistances. So that's lower current sources, high current source. I don't know what the current sources actually are. So could it be this chip here is dodgy, or is one of these resistors bad, or is one of these resistors bad? Unlikely to be a bad resistor. I mean, it can happen. So I'm just not quite sure what this bit here is doing. Alto isolator there, looks of it. Potentially. Not quite sure. Don't know, I'm not quite sure what's going on here yet. There's not much else in that path, so either there's a high resistance in this path which shouldn't be there, or it's just not generating the right voltage in order to create the correct current. So there has to be a current coming through here in order to measure a voltage across that shunt to know what the voltage and the current actually is, in order to do the ohms measurements and stuff. But the ohms is working. That's the bit I'm confused by, is that the ohms is working. Ohms current source, yeah, I did see that sitting there. Yeah, I'm not sure. mean, I know we're close to the bloody where the situation is going to be bad, right? Could it still be a bad shift register not switching something correctly, and so therefore something like this isn't switched properly? Should I be looking at shift registers? And don't forget, this particular error didn't even show up, this 304. But it's a reference measurement for 305.5 and 0.6. And both of those do show up as errors. What's throwing me here is that we've got this, which says should be 10 millivolts, and we're getting 4.7 volts. Because it's got 100 millivolts measuring at this region here, right? So you're getting 100 millivolts around here, which is then going to feeding through from here into the buffer and being multiplied by 50 times. So that's confusing. See, what's confusing me is that I tested the ohms mode and resistance modes, and they worked. At least 2-wire worked. Did I test 4-wire? Yes, 4-wire worked as well. I did check both, and both 4-wire and 2-wire resistance worked perfectly. So if resistance was having trouble, then I'd be more comfortable about it being a resistance or ohms source error. But the fact that they work perfectly throws me a bit, because it's like, well, how can it be an ohm source error if the ohms worked perfectly? Because surely that would show up as an issue. It's not quite making sense to me about what's going on. Not sure. This might require a bit more thought. I don't know if you're using a parts cannon approach and just chucking parts in and go, it wasn't that. Ohms doesn't go through the branch section. Well, what I'm thinking is it must be measuring the voltage. Right, because this is where everything joins back together, isn't it? The through this section here and through this section here. So this is where it's actually measuring the result of the test, isn't it? So yeah, ohms is coming in here, yeah. Ohms is there. So that's the measurement side. Is in this side. Yeah, actually that's the point. So this is where it's feeding through the measurements to actually get that right, but how could it be getting the right measurement if the source was wrong? I mean, the source is obviously going through here. In some way. Those are the things. I wish these flags are a bit more obvious. I mean, the flags can be either mean a signal line or a main connection, so it's not always obvious about what these are doing, right? Those are connections to the front, like the front panel terminals, right, from what I can tell. But then these can also be signal lines. Or are they going to the front panel as well? I don't know. Yeah, okay. Yeah. Yeah, because you think the voltages coming out here would be the same as that, wouldn't you? You'd think they would match, wouldn't you? Right. 332. Let's go and find that then. There's 332, so big chip right there. Can you see what I'm doing? That's my camera turned off. My camera has turned off again. Wake up. I was short is on when I come over here. Must have turned off as I got here. Right. It's okay, I noticed this time. It's alright, you noticed this time. So there's 332 right there, that big chip. So we want measure pin 1, 6.4, pin 2, 0.38, pin 3, 6.4, pin 4, 0.35, pin 5 is 0.38. So pin 3 was the input, wasn't it? Let's go back and look at the diagram again, I've forgotten. Geez, my short-term memory is getting bad. So 3 is the input, that's much higher voltage. So at least we find out which resistors should be turned on. So 1, 2, 4, 5. So the one which has got the highest voltage on should be the one which is using it. So should be one of them, shouldn't there? So 1 is highest voltage, 2 is low, 4 is low, 5 is low. So pin 1 is the one it's using, and that's going straight through. Okay, so in that particular mode, in that test stage of 309.4, it's going through the 750 ohm resistor. Right, so it's so if I've got 6.4 volts on one side of that resistor, hold on, we can work this out. Where's my calculator? Call it 6.4, and we've got what do you have on the other side? Jeez. Pin 7 or 323. Or 0.38. Near enough's going to be good enough. It's not going to be perfect. That gives us a 6 volts drop basically, 6.02. Divide that by 750. That gives us 8 milliamps. Okay. That says 9.2 milliamps. Yeah, it's close. Don't think I just did rough values, didn't I? Is this an error? So all these are shut, open, right? So let's just come back here. So that's open, that's open, that's open, that's open, that's open. So there should be no current draw through any of these paths. So it should only come through here, right? Where does that go? I know I have seen other amps flags. I just don't remember where I saw them. Front rear switch. Got amp in there. I don't know where the front rear switch was. There's amp in there. Where was it? Just got aimlessly wander around trying to find a damn thing. It's probably on the page below the one I was looking at, isn't it? It's going to be the very right down the bottom bar. I wasn't looking. Let's get down one more page. Here it is. Right, okay, so that's a switch straight in then. Right. Right, yep, okay, got it. And my monitor just turned off so I can't see anything. It's been on for too long. It does that auto power saving thing. Turn back on, you bastard. Come on. See the power saving mode. Right. It's useful, but not when I'm trying to use it. Right. Now I've lost where I was there. Here we go. So that's the amps jack coming in. Straight across the shunt, straight across the stuff, straight across protection circuitry. So the only thing it can be then, if these are all turned off like they're supposed to be, maybe that's what we need to check. Whilst all things are supposed to be turned off, can we check for resistance between the shunt and say the amps jack and see if we've got any resistances here which shouldn't be there. Because right now, if I go amps to low on the front panel, I should measure nothing because it shouldn't be going through any of these things at all. All those should be open. The only thing it might be going through is this. And being diode bridges, it may not matter unless it's being influenced by this section. Let's just measure resistance across there and see if we've got anything in case one of the switches are stuck open, stuck closed, or leaking. I'll just tell you what I find, if anything. Wait for me to be up. Just gone to sleep. I'm measuring 133k, so that's not a shunt, is it? 133k rules out, well, all of that really, doesn't it? That level of leakage shouldn't affect anything. It must be coming through this, or this circuitry here. AC bootstrap. I don't know, I'm still confused by this. Yeah. I'm not getting very far. This is probably not making much entertainment. And it's gone 3 o'clock. I probably need to think about having a break from this and just let my mind absorb what I've seen so far, and it'll probably come to me later on and go, oh, I should have checked that one thing, and that would probably be it. You know, that's what happens because I need a break from it, you know. I think I might have to just walk away from this for a little bit and come back to it later. Yes. But 9.2 milliamps, we're getting about 8, which is interesting. Get about 8.1 or so, it's a bit of a difference. And this one here is also 9.2 milliamp source. 9.2 milliamp source. That was 302, wasn't it? 9.2 milliamp source, 0.98 milliamp source. Sorry, 0.98 amp source. Huh. Oh, mate. Is it? Am I out by one stage? No, it can't be. No, I think I'm reading that wrong. I'm pretty sure what's on screen is a stage it's currently at, because when you do enter, it goes to the next step. So it's sitting at 309.4 right now, which is this one, which is, you know. Okay.
Coffee?
Yeah, so I think about stopping actually because I'm getting tired.
Your plate?
No.
Sure.
Yeah, okay. let's look at the sample protection thing, because this is one of the things that's flagged up. And obviously we did rule out the diodes already. We checked them, they checked okay. The bridge looked good, the individual diode looked good. So, is there anything extra information here we can get from this which might give us something else to consider with that protection circuitry? So at 310.1 we should measure 1.7 volts A to D in. Let me just check this one. Manual self-tests. I want to do 310. My camera's going to sleep again. What's it going to sleep so fast? Interesting. Maybe it's just taking me that long to get around. Yeah, I don't know. Right. 310.1. That's what I've just selected. Step 310.1. Paused. Okay. Let's see what we're measuring here now. If I do voltage, it'll be much better. Be sure that's the right number. I'm sure that's pin 3 there, wasn't it? Let's just go to pin 6 on here. I'm sure it's the same pin. Pin 6 there. Yeah, it's the same. So that's not that voltage it said, but interestingly, for measure resistance, it's right. It's 1.7 volts, but I'll give 1.7 meg. Is that a clue? I don't know. I don't know. I'm going to turn this off and have a break, because I think I'm going a bit nuts with this thing. Yeah, so I don't know. So this 310.1 failure says it cannot measure 1.7 volts plus or minus 0.3 volts A to D in. And that's correct, we're not measuring that. So that 1.7 volts isn't there. So sources current on a 20 microamp range. Let's show you this. I'll even make it a bit bigger. There's the same test as that, right? Which is also failing. So it should be getting that much low resistance. So that should be using over here. This switch here, microamp range from it. Yeah. So it's using this one here. So it should be doing through this whole path. And it can't achieve the voltage. Now we know this path's good. At least those shunts are good. So either one of these is clamping it. It should be 1.7 volts. And we're getting, what we're getting? 100? Was it? I've forgotten now. So it's less than a tenth. So it'd have to be less than 100 ohms. we're getting 1 point. Was it 0.13 or something we were getting? Was it? So if that one there was leaky, could that be causing it to shunt through here? Because it'd be 1/10 of it, wouldn't it? The 2 milliamp one. But then we've already verified this one. Yeah, we already checked that one and it seemed okay. Going in circles now. That's not good. U325, part of current generation. Ground system and ohms current source goes to there and links through to those. Yeah, I should probably find out more information about these chips, these 14052s. Find out exactly what they do. I'm guessing it's an MC14052. Multiplexer, demultiplexer. That sounds right, doesn't it? Dual 4-channel. That looks right. Yeah, there's multiplexers. I'm just having a little bit of a look at the datasheet for these things. Actually, I might just save that. Let's do that. And the way Safari will, I'm trying to zoom it in and it scales it back down again when it gets to a certain size. It shrinks it back down. It's like, I don't want that, I want it bigger. Anyway. So it is indeed switching that through to each one. Seven and 8 V and E VSS, yes. 6 is inhibit. So 6 is inhibit. 9 and 10 are the A and B inputs. I'm not quite sure if they switch together or not. Double pole 4th row, so effectively they must switch together then. So those, so pin 1 is on, so then for pin 12 must also be on with 13, which means that'll pass through here and into there. So it's switching that through to here to that device. Okay, so then that'd be doing that, the voltage up to there, which we knew about. And it also means it's going to be passing through to this one, to ground. if that one's on, which it won't be because it'll be separate. So we're switching these somehow as well for current source into that side and into that side. Not quite sure how that's doing that. Maybe it's for extra current handling. Not sure. There's a 100 meg resistor there. And this section. Yeah, I don't know. I don't understand this yet. Yeah. So we verified it's getting through here, right? So that one to there is working. I think it's passing in there, out there, not the other way around. So it's coming in here, in 13, out of 12, back into 1, out of 3. I was also switching this one on. So in that case, I should probably measure here. 13, and obviously you know what that one is. I'll take it and turn it off again now, haven't I? I have to go back into the measure mode. Yeah, so measure 13, if that's at 6.4 volts as well, then we're not losing it through there. Then we have to check this one and see if it's coming through the ohms cal. Not sure. Yeah, so anyway, I've got some things to look at, but I'm getting a bit fried now. I've been thinking about it too long, so I think it's time to have a break and do something else for a little bit and absorb. It's just a bit frustrating. I spent most of the day on this thing and achieved nothing apart from recapping it. Yeah, so that's a bit annoying, but I'd hope they actually get the thing fixed today. Not to be. So to find a bad switch. This is when I find out X was exactly right, and he said, to just replace the switches and they're done with it. I mean, I could have replaced all of the switches by now, and it could have fixed it. If it's even a switch, of course. It may not be a switch. So that 309.1, which is like the very first fault. I had this issue when I did the 2002. I mean, I was trying to go through this faults tables and track it all right down, and I got nowhere following the troubleshooting information. It just went through. It's like, yes, it's wrong. Don't know why. And I didn't find any faults at all going through the troubleshooting guide. I found it by accident, by randomly probing parts. Just trying to find a part which didn't look right. And that's how I found it. So, I mean, I found now that, it should help you, but I'm not actually sure it really is. So far, it hasn't helped. Yeah, so I'm thinking this. So the ohms test, the ohms works fine. Apparently, ohms calibrated okay, or something, I don't know. It said it failed calibration or failed test or something, I don't remember. Failed adjustment is what they said, failed adjustment. So maybe they tried to calibrate it and they didn't complete it, so they didn't actually save the calibration, which would be a wise thing to do, which is why it's not been calibrated for 6 years. So, and like I said, the ohms was working and measuring okay from when I did the tests. So I'm skeptical about the ohms being a problem, but it's linked into this system. So if your ohms current source is linked into this, and the ohms current source appear to be working correctly, because when I did the ohms measurement tests, they were working perfectly across all the ranges. that kind of confuses me a little bit, because is it this U323? Even though we kind of verified it's kind of right. I mean, could it be that I'm looking for leakage, dragging the voltage down, right? Maybe there's an internal fault with this switch which is causing it to drag down internally, not externally. Yeah. Maybe. It's a long shot. I mean, we've already measured it and it seemed to be working correctly. But it doesn't mean that it didn't have a additional fault path which drags it down. The actual switch is working, but could it be also shorted to something else internally? U322. That's the this thing here. Well, say DC volts works. AC and resistance works. Oh, this camera's already turned off again. Maybe it's because it's been on for so long it's overheating or something. And those all come through here. So it's all come through this buffer to go to the A to D. So if there's an issue in one of these paths, maybe it would show up somehow under certain circumstances. When that was low, we're getting the same low voltage right back here, right? So that was just passing right through as a one-to-one buffer. That what we're getting on the output of that buffer was the same as we're getting over here. So I don't think there's anything in that situation dragging it down, because you do have resistance through the switch, right? So if there was something dragging it down here, they would have seen a difference in voltage across that switch. So I don't think there's something in this section dragging it down, because you would have seen a differential across there. You know, is an insignificant drop between here and here. It's like almost nothing, 0.01 volts or something. It's like nothing. So I don't think there's a load on that side dragging it down. I think it has to be in here somewhere. But there's not much to this, is there? Now, something on this page, I think, could be wrong. Could be why I haven't found it. And the ohm source stuff's right. We've got these selections here. We've got these comparators for range selections. And we've got this overload protection thing here as well, but I don't think that's as the other ranges all work, or the other modes all work. Overload protection's got a reset circuitry. It looks like it ties into reset circuitry. Interesting. I don't know. I'm at a bit of a loss right now. This isn't very conclusive, very exciting live stream, but I can't figure out what the hell is wrong with it. And I'm sitting here for hours pondering. Well, we did that. Well, I kind of did that with the. Well, I measured the voltage between that pin 7. Now, I know the voltage is at pin 7, and we knew the voltage was here at pin 1, right? So that was that 6 volts differential between those, which means you've got 6 volts across that resistor, which means we're getting about 80 milliamps. You'd lost an hour ago for it. That's okay, that makes 2 of us. Yeah, so because of the voltage differential across here, we're getting 80 milliamps. In theory. Which wasn't what it's supposed to be getting either. It's supposed to get 92. I mean, obviously I did ballpark measurements. It was close to that. It could have been slightly more. Might be slightly more than that. If I do it more accurately, actually, let's do it more accurately. Was it 6.47 volts minus, what the hell was the other one? I can't remember what on the voltages. Was it 0.13? No. Was it 0.13? Boy. That's 84 milliamps. So it's 130 millivolts at one end. And it becomes 84 milliamps, which is getting closer to what it should be. So I don't know. Okay, I think I'm going to have to call it a day and just stew on this one a little bit. I was hoping to get this thing fixed and, done and dealt with. And then I was hoping to maybe move on to something else, which is why I've got this stack of stuff over here on the desk here. And, yeah, it's not been that productive, is it? At least we recapped it. Not very well, but recapped it. But, yeah, I would have liked to have actually got some progress on fixing anything. Okay, I think I'm going to call it a day. And interestingly, haven't dropped a single frame all stream. So I've been streaming for... How long was that? Jesus. Nearly 8 hours. Yeah, nearly 8 hours stream. And haven't dropped a single frame. That's good. That means I can probably increase my bitrate next time. Thanks, Corey. And thanks, David. Yeah. Interesting, yes. It's more interesting when you can nail down what's causing it. Obviously, I'm going to carry on working. Still going to have a break and stuff, and I'll probably maybe tinker around with it some more tonight and see if I can figure it out. Stream moves 50% of your ability. Yeah, it does. It does divide your focus quite a lot, and it breaks your focus up. And so I do find it harder. It definitely does take me much longer when I'm working on something. When I'm trying to repair something, whatever I'm doing, it definitely takes me considerably longer when I'm doing a live stream or recording video, one or the other. Live stream's worse. Video also slows me down. I did find that because it's split focus. But the thing about live streams is people can interact and give their input and help me to try and figure out what the hell's going on when I'm lost, like I am right now. So anyway, thanks for dropping by. Hope you found it interesting, and I don't know when the next live stream will be. It's when I get the chance, when I get the motivation usually, and yeah. Otherwise, you will see the video on this thing come out at some point in the future when I actually get it fixed. Hopefully, it will happen. It doesn't matter of figuring it out, as it always is. So, catch you later. I'll do it this way. Do this one. See you later.